organized by Oil Technologists Association of India Eastern Zone, co-organized by Jadavpur University. We look forward to another day of insightful lectures, academic exchanges, and meaningful discussions on emerging sustainable technologies in fats, oils, food, and allied industries. We will start our program with powerful quotes of Swami Vivekananda. All power is within you. You can do anything and everything. It doesn't matter how slowly you go as long as you do not stop. Yes, we will not stop, and to nurture our imagination, our thinking, we gathered here. We now commence the proceeding of day 2. At the very beginning, I am requesting to all of you, please keep your mobile in airplane mode, please. To begin the academic program of the day, may I invite Professor R.K. Trivedi, visiting professor, former professor and head, Department of Chemical Technology, Oil Technology, School of Chemical Technology, Harcourt, Butler Technological University, Nawabganj, Kanpur, to address the gathering. Professor R.K. Trivedi, please.
Good morning to all of you. I have been asked to say a few words before this session, and in fact, the person who was supposed here to address, he is not here today. As you know, the subject of this conference is emerging sustainable technologies. And sustainable technologies will be also deliberated in next technical session. And a lot of things are happening worldwide, you know, in different areas and related to sustainable technologies. There are technologies which are also called as green technologies, and there is also a lot of discussion on circular technologies. I think we'll be deliberating on these issues, and there will be expert lectures also in this session. There are 3 speakers in this session, and who will be talking more on this area. They are expert in this field. They have been practicing these technologies for a long time. So I think the session will be very useful, especially for those who are here to listen more recent advances in these technologies. And I'll be speaking more in the next technical session, which is chaired by me and myself, and there are 5 speakers in that session also. So we'll be talking about sustainable technologies and especially focused to oils and fats. Thank you very much, madam.
Thank you, Professor Trivedi. May I now invite representative of Spheritech, Rohan More, to say something about packaging materials of his company. Mr. More, please.
So, good morning, everyone. So, myself, Rohan More, and I'm from Speartech Packaging, where we are into the packaging machines for the liquid product. So, yesterday, on day one, we explored about science, sustainability, innovation behind the oil and fat ecosystem. Right from the advanced biotechnology to the sustainable oilseeds production. We also heard about green process initiative, then commercial and sustainable, and the importance of ISO and FSSAI. So today we will move to the next chapter, that is the journey of what happens after the oil is been produced. Because once the oil is refined, purified, and ready, it still needs a pathway to reach to the customers. And that is where we come in. So our role at SpearTech is to take the finished product and ensure it is filled, packed, sealed, and coded, and make retail ready through our high precision, sustainable packaging lines. Basically, we are the bridge between the oil manufacturers and the consumers. In next few minutes, I'll walk you through how filling packaging technologies enable oil manufacturer to deliver quality, safety, reliability at scale. And as you say, like at SpearTech, we summarize ourselves with we fill what flows. So now to give you the overview about SpearTech packaging, we are into packaging industry for more than 2 decades. We have been, we are the first one in India to introduce a PLC-based flow meter systems in India. So we have more than 3,000 plus installations in India, plus around 1,000 plus installations across globe. We have supplied machines to Africa, Middle East, Southeast Asia. So these are the industries that we cater. Majorly, our 70 to 80% of the machines are into edible oil as well as in the lube oil. And then the sectors that we cater are pharma, dairy, water, pesticides, home care, chemicals. So this is our product portfolio. Like we provide end-to-end solutions right from the blowing machine till the palletizers, like blowing machines. Then you have rinsers, fillers, cappers, labelers, batch coders, inspection systems, case packers, and then the palletizers. So after this, after the presentation, I will show you a video of our filling lines so that you can get a better idea about how the systems are being inlined. So coming to the filling machines, we have multiple filling lines. Basically, we have into the linear fillers as well as in the rotary fillers. In linear fillers, we have multiple principles, like we have flow meter based machines, we have load cell based machines, we have piston based machines. And also in the rotary lines, we have volumetric fillers as well as weighmetric fillers. So this is the volumetric machines, which is, this is basically the first machine introduced by ourselves with the flow meter based and a PLC based controls. The flow meters that we used in this are our patented flow meters, which are developed by ourselves, which gives you an accuracy of about 0.1 to 0.25%, be whatever your pack size is. This another machine is a weighmetric machines. So this is used in the industry majorly to fill the tins, as well as your jerry cans, 15 liter. And the principle of this is load cells. So each and every nozzle will have an individual load cell so that you get an individual accuracy in a container. These are the high-speed lines where we fill the bottles from half a liter to 1 liter and maybe more than 5 liter, up to 5 liters, where you can have a speed of about 150 bottles per minute. Another one, this is the rotary machines by weight. Again, this in India, we are the only manufacturer, Indian manufacturer, to make a rotary machines by weight. PLC, which is PLC operated, and individual load cells for the individual nozzles, which gives an accuracy of about 0.1%. So this is another technology that we represent a cryogenic cryogas systems, which is into liquid nitrogen dosing. This is a new concept in India where the liquid nitrogen is dosed into the bottles so that you can increase the shelf life of your product, and also you can reduce the packaging cost by reducing the cost of PET. These are the piston fillers. Again, I will not go much in detail about it. Then we do cappers. We are into different capping machines, like we have for the screw caps, for the snap-on cars, for the ROPP caps. So we have a linear as well as rotary model also for it. Then we do labeling machines also, the label that we can see onto the bottles of our containers. Based on the bottle shape and size, we have the its application. Like if you have a round bottle, we go with a wraparound labeling. If you have a square jar, we go with front and okay, fine, sure. So this is another than sealing machines, which gives a tamper evident proof for your cans. Then coding and markers to do the MRP as well as batch coding. This carton is the final product where we can tape the boxes with top and bottom. Then we have a case packers. We do case packings for the bottles, so pick and place machines, where automatically the bottles are pick and placed into the cartons. This is a representational diagram where we have shown the entire line, how the line has been done. So, as I said earlier, like we have more than 3,000 plus installations in 35 plus countries. That's our factory. Thank you. I'll just go quickly run through the videos also. Show kar do na. So this is the blowing machine. From blowing machine, with the help of the air conveyor, we do supply the bottles to the filling lines. The line speed of this is 100 bottles per minute. I'll just quickly run. So Spanpack is our brand name. It's a monoblock machines where the filler and capper is in a single cabinet. This is a labeling machine. This is a wraparound labeling for the round bottles. Coding machine for batch coding. This is the pick and place machine. That's the taping machine to do the taping with top and bottom. It's an automatic machine. And finally, we have the checkware, so that if at all there is any shortage of bottles, it will automatically reject the bottles. Okay. Thank you. Thank you.
Thanks a lot, Mr. More. May I now request Mr. Surya Agarwal from Boj Refinery, well known by its product Doctor's Choice, Dil Ki Choice, on dais to say something about his company and products. Mr. Surya Agarwal.
Good morning, everyone. How are you all doing? Good morning. Can we show some more energy? Can we all compensate for the empty seats? Good morning, everyone. Okay.
From Dil Se.
Thank you so much. First of all, I would like to thank everyone from the OTAI for organizing this wonderful event, and also my team members JP Singh ji and Ritika ji, who came on a Sunday morning to help us with this event as well. The most important part of any event is to make sure that there is a thoughtful exchange of ideas. And we have a lot of veterans from the industry, experienced professors, and enthusiastic students who can help us with that. So I want everyone to make sure that you get the best out of this event. And we would also like to thank OTAI for giving us the opportunity to be a part of this event, and I look forward to making sure that we are able to help out the enthusiastic professors and students in future as well. We have our foundation, and our company was started by late Shri Pawan Saraf, and we are trying to take forward his vision, and we have grown over the years from 300 tons per day to 1200 tons per day, and this has all been with the support of all the technologies who have helped us evolve, and all the customers who have shown trust in our products only because the technology has enabled us to do so. I would also like to share one feedback. Yesterday, when I was trying to find out about this event on LinkedIn, I could not find anything. I don't know whether something has been posted or not, but LinkedIn is something today that is used by the entire industry, and we need to make sure that regarding the event, we are also present on LinkedIn with the entire details, agenda, everything, so that whenever somebody is searching in the industry what's going on over here, they'll be able to readily find out and participate. And that will again help us with the expansion of this entire wonderful community. Apart from this, I would also request everyone to please visit our website, bajajrefineries.com, so that you can help us with your suggestions, your feedback regarding how your ideas can help the world. Thank you.
Thanks a lot, Mr. Agarwal, for your brief address. Thank you. Thank you once again. We now move to the first invited lecture of the day. Now, may I invite Professor Kakuli Bandopadhyay, Dean of Academics, Department of Food Technology of Guru Nanak Institute of Technology, West Bengal, for her invited lecture on enhancing oxidative stability of edible oils using black cumin seed oil, a natural antioxidant approach for improved frying performance. We are pleased to introduce Dr. Mrs. Kakuli Bandopadhyay, Professor and Dean, Academics, Department of Food Technology, with an MTech and PhD from the University of Calcutta and a University Gold Medal to her credit. She has been a distinguished academic and researcher since 2004. Her work spans waste valorization, functional foods, nutraceuticals, and edible oil technology. She has published over 60 research papers, authored and edited books with leading publishers, and holds 1 granted and 9 published patents. A life member of OTAI and IEI, she is the recipient of several awards. Professor Bandyopadhyay, please. Before her presentation, we want to felicitate Professor Bandyopadhyay, and she will be felicitated by Professor Amit Pratap, Secretary, OTAI, Western Zone. Professor Amit Pratap. To Professor Bandyopadhyay from Professor Pratap. Thank you, thank you. Professor Bandyopadhyay, now podium is yours.
Very good morning, all the dignitaries present on and off the dais. First of all, I would like to thank Oil Technologists Association of India, me also a life member of this organization, for organizing this international conference, particularly in Eastern Zone. And that will be very much helpful for Eastern Zone people. And of course, inviting me as the guest speaker in this conference. So today, just I am starting my this research, actually research activities done by my PhD student, She is Dr. Shairi Ganguly. That research work I am just sharing with you. Now, this concept is actually coming from that. We know that from very ancient days, we are popping the seeds, that is called the foron, in oil before cooking. So what is the scientific reason behind it? There must be some scientific reason. Only just because of not the taste, T-A-S-T-E. There must be some T-E-S-T factor there. That's why we are using that. So this concept is coming from our ancient, that common thing that we are doing before cooking. So here black cumin seed is added in edible oil to enhance the antioxidant approach. Of course, here we are using some multi-sourced oil where we can actually balance the SAFA, MUFA and PUFA content of the oil. This is the session flow. Now, introduction that I already said that here actually we are using both the fenugreek seed and black cumin seed for this purpose, to enhance seed oil actually, to enhance the oxidative stability of the oil and to get some of the say characteristics of it, so that after multiple cooking the oil quality remains constant, or sometimes it will be as per standard. The objective is, of course, to evaluate the antioxidant effect of, first of all, the fenugreek seed oil as well as the black cumin seed oil, to enhance the frying stability of soybean oil and rice bran oil both. And here we are comparing the flaxseed oil and this black cumin seed oil, the effect of it, the thermal degradation during heating. Of course, here adding just 1% black cumin seed oil, which can enhance the oxidative stability for multi-sourced edible oils during continuous heating, even in this temperature range. Analyze the impact of black cumin seed oil on chemical properties, fatty acid profiles, then thermo-oxidative behavior, and of the multiple source edible oils after prolonged heating. And of course, to determine the change in oxidation kinetics after the addition of this black cumin seed oil. Now, these are the literature. The methodology, of course, here we are using the black cumin seed and fenugreek seed oil after solvent extraction, and normal hexane under normal or ambient temperature or cold extraction, we are utilizing this for extraction of this fenugreek seed oil as well as black cumin seed oil. And the potato chips actually fried in rice bran oil and soybean oil with and without addition of spice oils. Then analysis and effect of the spice oils over soybean oil and rice bran oil at time of frying. Of course, its viscosity is also measured, as well as the change of acid value, because we know that if we are using or heating the oil for multiple time, there of course there is an increase in their viscosity due to the polymerization will happen. So viscosity, we are keeping it was important parameter for discussing the stability of the oil or deterioration of the oil. Preparation of this multi-source edible oil containing soybean oil and palm oil, then addition of black cumin seed oil in soybean palm oil blended, thermal treatment of multi-source edible oils with and without addition of black cumin seed oil, and their analysis effects that is given here. This is the actual flow chart that we are following for the frying of potato chips, the common flow chart that I am using here. Both the effects has been done or discussed both for rice bran oil and soybean oil after frying. Now, these are the procedures. What are the components we are taking here? Soybean oil plus 1% fenugreek seed oil, Then soybean oil plus 1% black cumin seed oil, designated as SBOF, SBOC, then RBOF and RBOC. Now, these are the analysis of the effect of spice oil on soybean oil and rice bran oil at the time of frying and changes in viscosity. You can see that for soybean oil, these are the F means the fenugreek seed oil and C means the black cumin seed oil. These are the effects, change in viscosity after frying. Similarly for rice bran oil. Now, in further study, I am showing you the effect on soybean oil because we know that rice bran oil is already blessed, having some good amount of antioxidant present in it, and further studies were done for soybean oil. Now, analysis of the effect of spice oils on soybean oil and rice bran oil at the time of frying depending on its acid value. And the parameters are, the changes are actually after fourth frying, what are the changes happen, that is given in percentage basis. That is for SBO, this is SBOF after fourth frying. Then SBOC, RBO, RBOF and RBOC. Now, if you just analyze that, or you can get this, that black cumin seed oil is better in controlling the oxidative stability of the oil. So, for further study, I am showing you the effect of black cumin seed oil on the multi-source edible oil. Black cumin seed oil, of course, more effective than fenugreek seed oil in inhibiting the frying deterioration or to increase the oxidative stability of vegetable oils. Preparation and heating of the, now it is the question of multi-source oil or blended oils containing SBO and PO, addition of 1% black cumin seed oil. These are the nomenclature. SPO 20 means SBO PO ratio 80-20, then 70-30, 60-40 and 50-50. Considering the palm oil percentage, it is designated as SBO PO 20, SBO PO 30 and 40 and SBO PO 50. And when we are adding 1% black cumin seed oil, these are designated as just the addition of C is here, considering the addition of 1% black cumin seed oil in the multi-source edible oil. Now, these are the methods by which we are producing this multi-sourced edible oil. And after 6 hours of heating period, the oil samples were named as SBO20H, SBO20CH. Accordingly, the name showing that just H is included, that is the heated oil after 6 hours. These are the analysis of chemical properties in terms of acid value after 6 hours of heating. If you are comparing this is a comparison between SBO20 and SBO-PO20 and SBO-PO20C. You can see the acid value range from 0 to 6 hours of heating. Similarly, this is the question for SBO30, where PO percentage is 30, that is 70-30 percentage, and containing C, that is 1% black cumin seed oil. So, the changes are remarkable from this graphical representation. Similarly, for SBO40 and SBO40C, as well as SPO50 and SPO50C. This is the analysis in terms of another parameter, that is peroxide value. Here are the changes that you can see from the graphical presentation. Actually, if we are considering SPO30, The changes are not very remarkable, but in case of SPO50, of course, the palm oil percentage is greater. Here the effect is, we can see that is the remarkable effect in terms of peroxide value. That is quite natural because here there is increase in palm oil percentage. That is in terms of para-anisidine value. Here again remarkable changes are showing considering all the percentage and considering the incorporation of black cumin seed oil in different percentage of SPO, that is soybean and palm oil blended oil. That are in terms of Totox value, chemical properties in terms of Totox value, of course. Now this is the fatty acid profiling. If you are considering that, just compare it in terms of SAFA, MUFA and PUFA of multi-sourced edible oil after 6 hours of heating. You can see that from the color it is identified that SPO20H after heating, the SAFA percentage, MUFA percentage and PUFA percentage. You can consider just one color in that way. And if you are comparing this with, say, SPO20 and SPO20CH, just if we compare these two, just see even after heating, the percentages are remaining almost same in case of SAFA. In case of MUFA, C, and that is in case of PUFA, of course, there is, these are the changes. This is a detailed fatty acid composition. We can get more, I think, clear idea if we are considering the fatty acid percentage in terms of this fatty acid like stearic acid, oleic acid, linoleic acid, linolenic acid, and palmitic acid. So, just compare these two. These two, 4.09, 4.6. We are comparing SPO20 with SPO20CH. Similarly, SPO30 with SPO30CH. That means the effect of black cumin seed oil after heating, 6 hours of heating in blending. Not very much affected by this. This is another study of oxidative stability by Rancimat. Secondary products are actually here with the help of conductivity. We can get the secondary products or oxidized product obtained after oxidation. Effect of black cumin seed oil on IP value. Induction period actually and oxidative kinetics. So if you can go before that, kinetic study done with that, following this formula. This is, just see, the activation energy. See that SPO20 and This is SPO 30. If you compare this with SPO 20C, SPO 30C, the activation energies are increased. That means the stability increases during the addition of this black cumin seed oil in multi-sourced oil, edible oil. So by this we can conclude that this study focused on improving the oxidative stability of multi-sourced edible oil prepared from palm oil and soybean oil, which will actually give a balance between SAFA, MUFA and PUFA. Of course, the physicochemical analysis and fatty acid analysis, oxidation kinetics evaluation showed that incorporation of this black cumin seed oil effectively reduced the lipid oxidation. Then BCSO addition enhanced the overall thermal stability of the oil. Fatty acid composition remains stable even after 6 hours of heating with the incorporation of this black cumin seed oils. Oils containing black cumin seed oil exhibited consistently lower AV, PV, para-anisodine value, Totox values during oxidation. Increased activation energy and improved this IP20 indicate the greater oxidative stability against or oxidative resistance. Now, overall, we can conclude that this black cumin seed oil contributed a longer shelf life and better stability to the formulation of multi-sourced edible oil. These are some of the references. Already publication done by my PhD student, and of course I would mention here our beloved Dr. Moha Ghosh, who was also involved in this research work. Thank you, Mohadi. And this work is going on, and there is one granted patent that actually showing the antioxidant extract from peanut hulls, and here actually this patent is the outer coat of peanut. We are extracting this peanut hulls oils. That means the outer sheet coat, the shell of the peanut, that we are just throwing it in the train during our journey. Totally the wastage of food. So extraction of that essential oil from that peanut hulls and incorporation of it in the soybean oil will also enhance the oxidative stability of soybean oil. Already this patent was granted by me and my scholar, PhD student, Dr. Shairi Ganguly, and I must be very much thankful to my PhD student, Dr. Shairi Ganguly, for incorporating this work and helping me in this research work. Thank you very much.
Thanks a lot, Professor Bandyopadhyay. We want to memorize her presence. So now a memento will be given by Professor Patro, again, Professor Pratap to Professor Bandyopadhyay as a token of appreciation. Professor Amit Pratap, please. Thank you, Professor Bandyopadhyay, for the excellent presentation. Thank you. May I now request Professor Rekha S. Singhal, Head Department of Food Engineering and Technology, ICT Mumbai, to deliver her invited lecture. The topic of the lecture is Co-extraction of byproducts of food processing industry for sustainable production of bioactive oils and oleaginous formulations. We are honored to introduce Professor Singhal. She is Professor of Food Technology at the Institute of Chemical Technology, Mumbai, and a leading figure in food and bioprocess technology. With a distinguished career of over 35 years, she has supervised 50 PhD scholars and more than 125 master's students, contributing extensively to interdisciplinary research integrating chemical, biological, and engineering sciences. Professor Singhal serves as a scientific expert on committees of the Department of Science and Technology, Department of Biotechnology, and the National Board of Accreditation. She is a fellow of several prestigious academics. She also serves as associate editor of Sustainable Food Technology, a Royal Society of Chemistry journal promoting circular economy-based sustainable solutions. Before her presentation, we will just felicitate Professor Singhal, and she will be felicitated by Mr. Ajoy Kumar Mishra, Organizing Secretary, OTAI, Eastern Zone. Mr. Mishra, please. Thanks, Mr. Mishra. Now, Professor Singhal, podium is yours.
Good morning, everyone. Before I start my lecture, I would like to actually be grateful to the organizers for giving me this opportunity, all the officials at OTAI, and in particular Dr. Ranjana Das, with whom I have been in contact. I would also like to pay my respects to Swami Vivekanand ji, in whose name I'm standing here. The hall is in his name, and he's one of my idols. So I feel very blessed to be here. And namaste and good morning to everyone. I have chosen to speak on co-extraction of byproducts of food processing industry for sustainable production of bioactive oils and oleaginous material. And as we can see in the middle, this is an opportunity for converting waste into wealth. And on the other end, if you see, it is actually by using this technique, we can get materials where you do not have to worry about cholesterol, carbs, or trans fat. So I have tried to put this premise before I begin the presentation. Now, if we look at the plant extracts market, which includes oleoresins, essential oils, and even oils, we see that it is an increasing market, and the revenue forecast in 2030 is about 80.27 billions, and this market is growing at the rate of 11.3%. Now, when this market is growing, what they are looking for? This is, they are investing heavily in R&D, and they're looking for new innovations across food sectors which can cater to varying needs and requirements of target customers. And here, improvisation is the key word. Only with improvisation, we can actually harness this market. And this market has it's very huge across the globe, but in particular in the European subcontinent. Now, with just this brief introduction, I want to start by what is meant by co-extraction. Co-extraction or concurrent extraction can be defined as simultaneous extraction of valuable compounds of interest from two or more different matrices. That means we combine two different matrices and we extract them simultaneously. Now here, The selection of raw materials obviously is very important because they should complement one another. And it has lot of implications in improving nutritional, functional, and technological properties. And when we co-extract, we find that there are synergistic effects rather than the additive effects. And also, this technology or this approach actually allows you to reduce solvent and energy consumption. So if I want to blend the two extracts, I would rather, instead of extracting them separately and then mixing them, if I co-extract, this actually is very useful. And it also contributes to valorization and upcycling of waste. Now, what is upcycling? We have all heard about recycling, reuse. But upcycling is something where we are getting a product from a byproduct which is of a higher value. So this is actually coming up in a very big way in terms of circular economy. Now, just to give you a few examples, it's not a very new term, but it has got recognition recently. And this is one, so when we talk about extractions, it can be through various techniques. It can be through solvent extraction, it can be through mechanical screw pressing, and of course, we have other which I will come to, which is supercritical. Now, one example I want to explain the significance of co-extraction. This is an example where tomato pulp was actually mixed with broccoli, mustard, and other two mushrooms. And the idea was to actually extract the lycopene in the desirable isomer, which is the Z isomer. Now, why Z isomer? Because it has better bioavailability in the human body, and it also has higher antioxidant value. So what happens is the broccoli, mustard, and the mushrooms, they actually contain isomerization accelerating compounds, which are generally polysulfides, isothiocyanates, or iodine. And this blending also actually influences the solubility of the Z isomer of lycopene, which is what we want. So as you can see, the extent of Z isomer lycopene in the products, in the co-products, were ranging from 42 to 53%. But the major findings was that there was a conversion of the E isomer to Z isomer, and amongst the co-products which were evaluated, onion was actually the best. And the important thing is, E-lycopene is insoluble in ethanol, but when it is isomerized to Z-ethanol, it shows a very high solubility in ethanol. So actually, it has implications in downstream processing. This is another example where we have two algae. One is a microalgae, and the other one is a diatom. And they have actually oil. When you mix them together and when you extract them, we get an oil which is enriched with omega-3 PUFAs and xanthophyll. There are conditions given. Here the extraction is with ethanol and ethyl acetate. And the idea was to actually extract fucoxanthin. So fucoxanthin is present in the seaweed, and when you co-extract it, you get the fucoxanthin from the seaweed in the oil which is coming from a marine diatom and which is very rich in polyunsaturated fatty acids. Another example is a more recent one where pomegranate seeds, which are the byproduct of pomegranate processing industry, and green leaves were mixed together and the oil was extracted using mechanical screw. And it was found that the resultant oil had a higher phenolic and chlorophyll content, and obviously it was much better from the nutraceutical perspective. So it is just a matter of mixing the two and mechanical pressing, where you need to optimize your process parameters and evaluate the resultant oils. I now come to another technique, which is a green technique, and which is the supercritical carbon dioxide extraction. I understand that many industries and many researchers and even established academicians think that it is a very expensive technology and they do not look at it. But the fact is that this is actually not very expensive. The operating costs are much, much lower, but the capital cost is high. And there are many supercritical plants available across the world. And here the biggest advantage is that you can avoid one step of solvent removal completely. The time of extraction is generally not more than 3 hours. And there are many pros and many advantages to it if one is willing to look at it from an open perspective. Now, in supercritical co-extraction, as we can see, there has to be a source of lipid, which you can see with coconut and the 2 seeds, and you can have a bioactive source. This source, these compounds like astaxanthin, chlorophyll, lycopene, lutein, these can come from the byproducts of the food industry. But when you mix them in varying ratios, what happens is the lipid from the oil seeds, it works like a co-solvent. On the other hand, the bioactives which are coming, they stabilize the oil. So it is a what shall I say, a synergistic kind of approach where the bioactives and the oil are getting co-extracted, and the oil serves as a bridge between the extraction of the bioactive as well as the lipid. It is with this premise that this technology has come, or it can be used. Now, let me explain some examples where citrus, 2 varieties of citrus. One citrus, we have used the seeds, or the authors have used the seeds, and they have used the peel. Now, both the seed and the seed, actually citrus seeds have a very good amount of oil. Almost it ranges up to sometimes 25 to 30%. We simply waste it or we do not bother about it, but the seeds are having this oil, which is an edible oil, and the peels are having bioactives like limonene and many others. So when you actually mix them together in defined proportions and optimize your process parameters, you can get an oil which is enriched with antioxidants. And this would actually have even antimicrobial activities and many other advantages will be there. I will not read the slides, but I'm trying to explain the concept more than the values. Now, this is again an interesting case where rosemary, which is rosemary oil, I'm sure all of us know about it, but this rosemary and spinach leaves, when they are co-extracted together, we find that you get a rosemary oil which is enriched with phenolic diterpenes, and this oil not only has carnosic acid, but it also has beta-carotene, lutein, and the antioxidant activities of this co-extract is much, much higher. So spinach is easily available. Rosemary we are anyway doing. What is the problem in trying to sort of mix them and co-extract it? A similar example is reported for tomatoes and hazelnuts. So tomato peels, they have lycopene, and hazelnut has an oil. And when you mix them together and go for co-extraction, again, under optimized conditions, we find that you get relative abundance of cis-lycopene from the tomato peels into the oil, and which actually is much, much beneficial, and it makes it bioactive. These are some other reports which are there. There are very few reports on co-extraction, and with supercritical, even few. There are very few reports, but I appeal to this audience to please consider this and try to develop this, because it will give you many opportunities. Now, this is an example of a seaweed and roasted coffee. Seaweed has fucoxanthin, and roasted coffee has antioxidants. Now, we need not really use even the roasted coffee. After the manufacturing of instant coffee, whatever spent is left behind, the spent coffee also has oil, and it has many bioactives. So when you mix the two in defined proportions, as I say, you have to optimize it, and it has been found that you get an oil which is rich in fucoxanthin. Now, fucoxanthin has a lot of therapeutic potential, which is not the purpose of this talk here, but it is good to have this oil having fucoxanthin. This is another example of byproduct utilization. Shrimp waste, which is rich in astaxanthin, and mackerel skin, which is having a good amount of fatty acids. So again, this was mixed in 1:1 ratio, and there were all sorts of process optimizations with supercritical. Mainly it is the pressure, the temperature, time, and the flow rate of carbon dioxide. Now, when you optimize all of this, you will find that you will get an oil, fish oil, which is rich in astaxanthin, and not only that, this co-extracted oil exhibits greater stability than the fish oil, and it also has a balanced fatty acid composition. So what are we doing? We are taking two waste byproducts, utilizing them constructively to have an extract which can have a lot of value. This is another example where pumpkin seeds, which are again available in plenty, and the peels which we normally throw away. But if these peels are dried and powdered, we can, and optimize again, as I say, there are references given, we can have beta-carotene, tocopherols and phytosterols, and the oil quality is much, much better. So these are some examples where co-extraction can come. And this is a work which was done by one of my PhD students, Nupur, and we tried to extract flaxseed with spice blends. Now, what was the rationale? Flaxseed oil cannot be extracted, if you extract it by solvent, you need a higher temperature, and it actually degrades the flaxseed oil. If you go for cold pressing, your yields are low. But with supercritical, what happens? Because of the lower temperatures, you are able to recover the oil. And when we mix it with 3 spices together, we get a co-extract. And this co-extract is actually a very good, because the spice constituents are protecting the flaxseed oil, and the flaxseed oil is working as a co-solvent along with supercritical dioxide, carbon dioxide, and you get an oil which is very rich bioactivity. And this oil can be directly used as a flavorant. For example, in popcorns, we used it for dahi bhat, and even in cooked boiled dal as a flavor. So there are these kind of, so this was, I'm just giving the gist. Now this is another interesting case where, we used marigold flowers. We know that marigold flowers are a very rich source of lutein, and lutein is very important for age-related macular degeneration. So what we did was, we mixed these flowers with coconut, which is having the oil, desiccated coconut, optimized all the extractions, and we got a very good extract. And this extract, actually, we then used it to fortify butter and peanut oil, peanut butter and regular dairy butter, in concentrations or in ratios such that 1 serving of 10 grams of butter and 25 grams of peanut oil can give you more than 50% of our daily requirement of lutein. So it is very much possible. The lutein is not only bioactive, but it also gives color. So it serves as a dual purpose additive. And furthermore, the residue that was left behind, since there are no solvent residues, we could use it to add it to cookies, and that residue also could be fruitfully utilized. This is again one interesting application where we again extracted coconut oil and turmeric. Now the reason for this is because if in the literature, if we see, both turmeric and coconut oil are known to be beneficial for Alzheimer's individually. But when we bring them together, when they are co-extracted, you will have the beneficial effects of both curcumin as well as the coconut oil. And we did this, optimized it, and further we used it actually, for Alzheimer's by using rat experiments. And we did find that the proposition or the hypothesis that we had was very good. In fact, this work is published, and I remember when I was receiving the INAE fellowship, and the chairman asked me that out of all the work that you have done, which is the best part of your work? Now, I was obviously, for me, all my work was good for me. So I requested him, sir, can you please tell me, because I cannot differentiate. And this was the work which he had indicated that appealed to him the most. So this is something which is very important. And another reason I must say, why coconut oil? See, coconut oil has short chain fatty acids, and that has a better extraction by carbon dioxide. Plus, it does not undergo oxidation very readily. So that helps in the cause of such kind of bioactive extracts. Now, this audience, I'm sure, knows that, we have this parachute oil with hibiscus flowers, which are very good for hair growth. And so we thought, can we mix the coconut oil and hibiscus, dried hibiscus flower, and optimize the extraction under supercritical conditions, and then use this oil, evaluate the bioactivities, which we did. I am not going into the results of that. But we further thought that we should have at airports, we are not allowed to carry not more than 100 ml oil. So we thought, can we prepare a gel which can be just squeezed and you rub it between your palm, apply it to your hair, and whatever is left behind, you can rub it on your skin. So with that intention, actually, we tried to develop a oleo gel, hydrogel, and we fabricated a bigel. Now, I'm sure we know what are oleo gels and hydrogels, but I'll explain what are bigels. And further, what we did was the residue which remained, after the extraction, we used it to formulate laddus. And for publication purposes, we called it sweet confection balls. And it was accepted, it is published, just last year. Now, since I mentioned about hydrogels, oleogels, emulsion gels, bigels, these are new derivatives, these are new formulations, which actually requires a lot of efforts from oil technologists so that we utilize it gainfully. Now, as we can see, this is an oleogel, and here we are having oil as the continuous phase with the oleogelator. Then we have a hydrogel, which is where water is the continuous phase, and we have a hydrogelator like carrageenan and other agents. We can have both bigels and emulsion gels, where oil can be the continuous phase, and you can have hydrogel as the dispersed phase, or you can have water as the continuous phase, and you can have an oleogel as the dispersed phase. So these type of gel systems are coming up in a very big way in last 2 or 3 years, and we have a lot of scope to take this forward. So we did try to formulate some of these bigels, and this was the work which I mentioned, that we formulated a bigel and we used it for further application. This is, since I mentioned about oleogels, now oleogels can be prepared the conventional ways as I explained, but there is also a new way where we prepare an aerogel and allow this aerogel for the oil to impregnate this aerogel. So you get a oleogel. So that is what is called as the aerogel to oleogel kind of a template. We did this so that we could get an oleogel which is rich in beta-carotene. This is another example where we mixed watermelon seeds and peels actually from oranges. We optimized the extract, measured the D-limonene content, measured all the kinds of bioactivities, anti-diabetic, anti-obesity, anti-melanogenase, anti-inflammatory, oil binding, all sorts of experiments we did, and we converted into an oleofoam. Now, what is an oleofoam? You're having an oleogel, and when you whip it, it will entrap the air. So you can use it actually for plenty of applications. So this is something which is very new, and we have just published this in 2025. I'm just coming to the end, so I hope I'm not exceeding my time. Please stop me if I do. This is actually, olive oil. We know that olive oil is obtained by pressing the olive fruits and then centrifuging to get the oil. Now, in this case, there was a scientist who, at the point of milling the oil or crushing the olives, added olive leaves, tomatoes, spices, and grape and pomegranate seeds, and then filtered the oil to get extracts, just to give you an idea, which was resistant to oxidation, had higher chlorophyll, total carotenoids, total alpha-tocopherol, and obviously much better bioactives. The results were more or less similar with values here and there, but in general it was found that when the natural ingredients were added to the olives after crushing and during crushing, but after separation, the oils had much higher levels of bioactivities. So I would like to give some concluding remarks. Now, co-extraction as a technique can give a wide range of functional ingredients with tailor-made properties. It is a very interesting and sustainable way to valorize wastes and byproducts. It has commercial feasibility due to economics of scale. You do not need to modify any existing infrastructure. You have to just intelligently utilize your materials that complement each other by overcoming the deficiencies that are encountered with one single ingredient. And you can utilize, it can be utilized for lipid-based ingredients which are almost unexplored. We have a lot of resources where lipids are present in quite significant amounts, and this technique offers an opportunity. However, we should mention that we need to study the life cycle analysis and project process costing. Now, with this, I would like to thank the organizing team of the conference, ICT Mumbai, for giving me academic freedom, my students. I must mention Dr. Paromita, she is here, Professor Paromita, she is here. And when I started this work on supercritical carbon dioxide extraction, she was the first person who started this work. And today it's a pleasure for me to see her here and also to see that she has continued this work on supercritical extraction ahead. So I think nothing can give me more pleasure than that. So thank you, Paromita. And there are other students also. So I have had students and collaborators, funding agency. Now, like any state-funded universities, we are always short of facilities. So SAIF at IIT Bombay comes to our aid for a lot of instrumental characterization, and I thank them for it, because without them, we could not have done much. And I must also acknowledge Somnath Basak, who is my second last PhD student. And we developed this idea of co-extraction, and we have gone ahead. He is also a co-author in this presentation. So I thank you for your time and attention. Yeah, thank you once again. Namaskar to everyone. Namaste to everyone. These are the kind of projects or papers we are looking for in sustainable food technology, because I'm the editor, so it is my duty to also inform about this journal, where this has an impact factor of 5.3. It has come recently, and it has now become open access. We are trying to see how the resources that are available to us can be utilized in a sustainable manner for the benefit of mankind.
Thank you, Madam, for bringing this particular area of research here. I just want to add another thing. As you initially told that the capex is more and then operating costs are not that much, so we can compensate. One thing I want to add, maybe the other presence here who can note it. Once we extract the oil, then in case of supercritical carbon dioxide extraction, we are not getting the polar lipids, like phospholipids. So if the phospholipid doesn't come here in the oil, we remove the entire degumming step. And in the degumming step, we lose 1.5 to 2% of the oil.
Correct.
So if that is avoided, and if we calculate that, then it is even, the ROI is very limited, means very small. We can easily use for commercial extraction also. And I know that one or two industries, even in India, they are seriously thinking of supercritical extraction.
Yes, there is plant lipids, and there are a couple of big organizations who are into it, but I think that is all for export purposes, and our industries are not coming forward in the mistaken notion that it is expensive. I may also add that the solubility profiles can be altered by using co-solvents. So if you are interested, you can first extract your oil, and if you want to further extract your polar components, you can actually use some polar solvents and again run a supercritical. So you can actually even fractionate your materials. So important thing is there is no second step of evaporation of solvent. There is no concern about residual solvent, and the time required for extraction is much less. So it works at economics of scale. You cannot compare a laboratory, costing based on laboratory. It has to be at a higher scale. There are a lot of papers which are available which have compared the economics, and many of these papers, rather most of them, have demonstrated that the concept which we think is actually we are mistaken. So there is a scope for taking this forward. Yeah. Thank you.
Yeah, excellent presentation, Professor. I just have to ask you, if you have two feedstocks, two types of feedstock, okay? It's a co-extraction. Is the particle sizes has any effect on that?
Yes, particle size is also important. But then you will have to take the particle size of the combination together.
Okay,
You
not
can do that.
individually. Not individually, like.
Particle size, sir, has an effect on the extraction. There is no doubt about it. Actually, if the particle size is very fine, then it will form a compact bed and there will be mass transfer limitations. So your particle size should not be too small, neither it should be too large so that the extraction doesn't take place efficiently. You have to optimize the particle size. And along with the process conditions, you are right, the particle size also matters.
Thank you.
Yes. Done, na? Thank you. Yeah.
Thank you, Professor, for your valuable insights. We want to memorize her presence. A memento will now be given to Professor Rekha S. Singhal by Mr. Mishra, Mr. Ajoy Kumar Mishra, Organizing Secretary, OTAI, Eastern Zone. Thank you, Mr. Mishra, and thank you, Professor Singhal. Yeah. Ladies and gentlemen, we now begin the panel discussion on technology development in fats and oils. The session will be chaired by Professor R.K. Trivedi, visiting professor, former professor and head, Department of Chemical Technology, Oil Technology, School of Chemical Technology, Harcourt Butler, Technological University, Nawabganj, Kanpur. Our esteemed panelists for the discussion are Dr. Kingshuk Kumar Mondol, Consultant in Oil and Specialty Fats Project and Product Development, Mumbai, Dr. Pradosh Prasad Chakraborty, Chief Scientist, IICT, Hyderabad, India, Mr. S.K. Roy, former President, Oil Technologists Association of India, and Dr. Shamul Udhikari, ex-scientific advisor, Imami Biotech Limited. May I request the chairperson, Professor Trivedi, and our esteemed panelists to take their chairs on the dais.
ठीक है, ठीक है. It will be better to speak from here. No? You are hearing.
Now, felicitation process. Our session chair and esteemed panelists will now be felicitated by Mr. B.P. Manchanda, President, OTAI, Eastern Zone. First, to the chairperson, Professor R.K. Trivedi. Next, we will felicitate Dr. Kingshuk Kumar Mondol, again by Mr. B.P. Manchanda. Next, to Dr. Pradosh Prasad Chakraborty, Chief Scientist, IICT Hyderabad, India, by Mr. B.P. Manchanda, again, President OTAI, Eastern Zone. Thank you, Mr. Manchanda, and thank you, Dr. Chakraborty. Now, I am requesting Dr. Rajiv Churi. Dr. Rajiv Churi, National President, Oil Technologists Association of India. Please come on the dais. Thank you, Mr. Manchanda. Now, Mr. S.K. Roy, former President, Oil Technologists Association of India, he will be felicitated by Dr. Churi. Picture अच्छा होना चाहिए ना इसलिए सामने आना होगा. Thank you. Dr. Shamul Udhikari, ex-scientific advisor, Imami Biotech Limited, will now be felicitated by Dr. Churi. Thanks a lot, Dr. Rajiv Churi. Now our panel discussion will be going on, and this discussion will be conducted by Session Chair, Professor Trivedi.
Hello. It's working, I think. Good noon to everyone. We have a very eminent expert in the panel, from industry to academia and research. So there are few areas, in fact, you know that oil processing industry is a very complex and lot of challenges are there in the processing. And especially when we say sustainable technology, a lot of emerging areas are coming up. From green technology to circular economy as well as AI, that has been emphasized by several experts in last 2 days. So I will request our panelists to confine in one area that we have already discussed, and that we will be talking on those areas. You know that in India, especially from mustard oil to refined oils, from modified fats, biofuels, and there are a lot of products are emerging. And when we say expertise in that area is also very complex. Whether it is palm oil in India or even rice bran oil, which are major oils, at least in India, which are processed on larger scale, and they are also consumed throughout the country. What I feel that since I'm in this area since 1981, when I started my career in this industry. I worked in industry for 4 years, later on joined academics. So I have seen a lot of changes. You know, earlier India was self-sufficient and we were not importing much oils. But later on, since 94, 95, a lot of import started, and we were dependent mainly on import, whether it is soybean or nowadays palm. So almost 2/3 is imported oil we consume. And several changes are there in the processing aspects. And in our distinguished panel, I will just request the panelists to be brief because we have only half an hour in this panel. So first, I would like to request in fact, Mr. Pradosh Chakravarti to start the session. And I'll request him to, because he is expert in the rice bran processing, especially ICT has done a lot of work, and the palm oil also. A lot of changes are there. So I request Pradosh Chakravarti ji to focus on the challenges, especially on the sustainable technology, what is the topic of this conference.
Good morning to all of you. Am I audible? The mic is on? Okay. Thank you, the organizers. I must thank for giving me this opportunity. I could not come yesterday because of some official work, but I missed that yesterday's discussions. Here, Professor Trivedi has told me to concentrate on rice bran oil. And you all know that the oil which is most difficult to refine is rice bran oil. So we have lots of good things as well as bad things. So as a refiner, we always try to keep the good things intact and remove all the bad things which we don't like. So there lies the challenge. And rice bran oil, if you have the experience of refining, then you can refine the other oils very easily. The means if you see rice bran oil, the triglyceride content itself is very less compared to all other oils. So what are the other things present? Lots of antioxidants, lots of what are nutritional components. The fatty acid composition is very near to the WHO recommendation. And keeping all those things, then what are the bad things? The bad things are the color, bad things are high FFA, and of course gums and waxes. So these things we have to remove. Every part of these refining processes, we should have some new innovation to get the economically feasible way to get the rice bran oil. So one major issue when I started my career at IICT was most of the rice bran oil which we were getting was going for soap making. Though it has the fatty acid composition recommended by WHO, it has a host of nutraceuticals, but we could not refine. The major issue was we could not do physical refining. Physical refining, why we could not do? Because it had gums. So we identified that the degumming, if it is not properly done, then we cannot do physical refining. Then we came up with a process with enzyme. The students who are there, I'm seeing lots of students here, they may know that biotechnology you have already studied. So one of the major part is enzymatic reaction in biotechnology. That phospholipase A1 enzyme we used for degumming. And that degummed oil gave us the oil having less than 5 ppm of phosphorus when it goes to deodorizer or deacidification unit. So in that, we have done that one sort of, we should say, the paradigm shift in processing of rice bran oil industries in India. And India became the best or the largest producer of rice bran oil, and the quality of the rice bran oil is uncomparable. So if we do the chemical refining, then we get a better color, but all the nutritional components we lose. So keeping all these things in mind, starting from the degumming, then bleaching, then dewaxing, and every part we should have some processes. If I get a chance later, I'll discuss in details. Over to you, sir, the next.
Thank you, Dr. Chakravarti. Now I request, because we have been talking about emerging technologies, and we have expert and senior person in the panel, former president of FOTA, Sri S.K. Raji. So I'll request Dr. Roy to highlight some of the new technology which are available for commercial exploitation, especially in oil industry. Mr. S.K. Roy.
Thank you, Professor Trivardi. Actually, Dr. Pradosh has already given detailed information regarding the rice bran oil. Well, it is very rich in these micronutrients, oryzanol, tocopherol, tocotrienol, squalene. It is one of the nature's wonder, I should say. And as Dr. Pradosh mentioned, it is almost reaches this fatty acid composition of the WHO also. About the technology, there are a lot of difficulties and other things what he has told. I 100% agree with you. But the new technology, that membrane technology, which has been tried by the CGCRI here, is, almost about 10 years they are working, and I was coordinating this project here. Dr. Shivdas is sitting here. He was the principal investigator. If we talk on this subject, probably not a speaker will be speaking on this subject. So I'll be simply highlighting the merits of it, whatever was, taken on that, because it was taken to plant level also, not only confined to laboratory, but to plant level also. But the results which has been shown, that it is feasible, that it could be taken care of. You see, membrane technology in case of the arsenic removal in water, that has been very successfully done also. The CGCRI has a number of these things, and very recently Jadavpur University has also installed in Narendrapur. So that is also quite, how to say, in general, commercially, this is feasible, this arsenic removal and all that. But in case of rice bran oil, which is a very, how to say, nutritious oil, beneficial oil, and fatty acid compost reaches at WHO. But then again, it's a very difficult oil also, as Dr. Pradosh earlier has told. That I don't want to repeat all these things, that time is also limited. I would like to highlight a few points only, which has been taken care of. Dr. Shivdas is sitting here. You can talk to him after in details. He will provide you all the details. What has been done is a two-stage membrane filtration of the rice bran oil. And hexane micellar at controlled temperature for simultaneous degumming, dewaxing, followed by deacidification after chemical treatment. This is one. Since RBL oil, there are minor differences in the molecule sizes, There is the main difficult point of this, between the desirable constituents like triglycerides, micronutrients, and the impurities, such as free fatty acids and unsaponifiable matter and coloring compounds. The separation problem is addressed by selecting the ultrafiltration membrane. You have membranes of suitable pore size. Because they are in this CGCRI, they have got the expertise. That is the most important part of it. And which CGCRI has got the expertise, which other people don't have the access to that. So that is where they have got a edge over us. The project was given by the, the ministry for which I was coordinating with them. So that was the merit behind giving this project to them. So even though I was a coordinator, but he is the principal investigator, Dr. Shivdas, he is sitting here. And along with 4-5 researchers were also associated with that. And it has been found that this is, as I told you, selecting ultrafiltration membrane of suitable pore size, depending on the size and of the components to be separated. That is most important. At that part, they very successfully done. And the production rate is lower in ultrafiltration, smaller pore size, and this membrane filtration of AF is a higher pore size. So salient features are about the 50% removal of the color during membrane filtration, 90 to 95% removal of the FFA, and 70% of the retention of the oryzanol. That is the most important point. This nutraceutical oryzanol has a very, important role in the day-to-day life of the people, reducing the cholesterol. That has been also Sugano. Yesterday I was talking to that also. They have already established. And negligible oil loss also. Another thing. It has been shown that it is a 2.25%. This is how, and the costing also was done at that time. And the costing, it has been shown that, well, it can be taken care of. And this was done at a pilot plant where the solvent plant was available, but the refining was not done there. Refining was done at the laboratory level, and it was found to be quite appreciable. This color and other things and the micronutrients that could be retained also. So that way it is it needs further research. 10 years, however, they did it, but still in the commercial level that can be upscaled. So that was established. Even though I was a member of the Science and Technology Advisory Committee, I requested them to allow them to continue to for a further period. But well, because it was going to be a lengthy period, and the government has got certain, these obstacles also in various places in the organization, other places to release certain things and all that. So it could not be done further. I believe there is a commercial prospect of it, and a further work could be done on that, and this is commercially viable project. Thank you very much. And in case if you want further details, he is sitting there. So if I talk on this subject, the whole time will be taken care of. It's such a big matter. But in short, I have given the gist of it. Thank you very much.
Thank you, Rashab. You know that oils are consumed in liquid form mostly, but a lot of work and a lot of research and several innovations are there in restructuring the oils converted to confectionery fats and several modifications, and especially the new legislations on the use of hydrogenated fat. Innovations are emerging. So we have expert here, Dr. Mondal. So I request Dr. Mondal to highlight the processing aspect in that area. Dr. Mondal, please.
Thank you, sir, for allowing me to give my impressions about the advanced fat technology now running in India. I think I am audible. See, India was originally the requirement of the Bonaspati. Now India is about 0.7 to 0.1 million millimetric ton per year. This requirement of Bonaspati is not increasing further due to the restriction of the trans fatty acid and also the FSSI restriction of the today's product. Now, India is moving slowly towards, and this was mainly being done by hydrogenation. Now, since due to this restriction has come, earlier much earlier than European country was maintaining this restriction. But last few years, several years, now India also has started putting this restriction. So their Indian government is also not allowing any trans fat acid more than 2% in the final product. So all these hydrogenated product now slowly moving towards the molecularly structured specialty fat, which is mainly done by fractionation is one of the technique, by fractionation of fats. Another technique is the interesterification of fats, both chemical interesterification and also the enzymatic interesterification. Mainly these two techniques, and the fractionation process is widely applied for Indian industry. Both dry fractionation, solvent fractionation is restrictively applied because it involves a lot of cost, project cost, but dry fractionation is being largely applied. So I will tell you, for the bakery shortening and also for the cocoa butter substitute fat, mainly we are applying for palm kernel, we are doing palm kernel fractionation for doing the CVS. And for the bakery shortening, we are mainly doing the fractionation of palm stearin, further fractionation of palm stearin to get the bakery product. And also, to some extent, also still today the hydrogenation is applied. But hydrogenation is applied in a different way. We are making zero trans fat, totally hydrogenated fat, about 1 IV, and that is being interestified with the liquid fat to make the bakery shortening ingredient. And mainly our demand is increasing both in bakery fat and also the CVS. CVS, which is mainly coming from the palm kernel oil fractionation, followed by interestification. Palm kernel oil fractionation, we are getting palm kernel stearin and also palm kernel olein. This palm kernel stearin is widely used in so many chocolates. And some advanced CB, that is non-lauric cocoa butter equivalent, that we are getting by the solvent fractionation of some of the Indian fat also there, that is like shal fat, like mango fat, like dhupa, several. By doing the acetone fractionation, we can get this cocoa butter equivalent, which is very highly costly product. Mainly we are, in India also we are now producing, and mainly they are exporting that product for last 20, 25 years for the foreign countries to get the better chocolate. Now, one of the concern here, there are so many industries in India, we are also having a very high potential of this non-lauric fat, which is sal fat, mango fat, dhupa, etc. We are having a very high potential. And by the utilization, we have almost a sal fat potential, sal seed potential, almost more than 6 lakh tons, 6 to 8 lakh tons. But we are not totally using this potential for making our cocoa butter equivalent. Mainly, possibly one of the fear that it has got a very high cost of project. But to my experience in this area, I know that it is not so, and even this sal fat, mango fat, and this other, say, Indian available fat can be converted to cocoa butter equivalent by dye fractionation also, that is without using the solvent. And it is a very, very high margin project, you can believe. By the processing of 1 ton of sal seed, we can make a profit of more than 25,000 rupees, which possibly our entrepreneurs may not know because they don't have that so much of technological idea for which they may not be coming forward. And one of the things we are losing here, because by the collection of salt seeds, these village dwellers, their collection of the salt seeds, and this is by collecting more salt seeds, they are living their, earning their livelihood. So more collection of salt seed and more collection of sal oil can even utilize, can give them a better life. So in my last lecture in FOIC, I invited Indian entrepreneur also. I gave the brief idea of this technology, the how sal fat, mango fat. Of course, I told about the shea butter also, which is available in Africa in a very large quantity. But some of the entrepreneurs in India also is importing the shea butter from Africa. And from here, they are again exporting towards all Western countries, Even that is also a very, very large, very high margin project. You believe 1 ton of shea butter, 1 ton of shea seed, if you process, it has a margin of about $400, meaning about 32,000 of rupees per ton. So, and also our India is tremendously increasing the requirement of cocoa butter substitute, which is obtained from the palm kernel oil. And in India, I think we have maximum 10 to 12 fractionation unit for the making cocoa butter equivalent and cocoa butter substitute. So, and rest of the cocoa butter substitute is being imported. But Indian entrepreneur can easily enter into this market, that they can not only, that will be not only fruitful for our own consumption, as you all know, that generally we are, our food habit is generally changing into the new generation. They are all employed, young husband, wife, and small family. They don't get time to cook foods in the home. So ready-made, this cocoa butter substitute product, which is used in chocolate, which is used in ice cream, which is used in different type of coating, is highly used, and its use will be continuously increasing. But still, this demand is also not being fulfilled. That is also, I think, for some lack of initiative from the entrepreneurs, also from the lack of our side also to convey them that this is not a very high-cost industry. Their investment also is very minimum, you know. Even this sulfate, mango fat, as I have calculated, this, if you have this solvent extraction plant and refinery, by involving in few crores rupees only, even 2-3 crores rupees only, you can go for the dye fractionation and make cocoa butter equivalent salt stearin, whose cost in the market is $7.5 thousand. This cost has so increased. You can just imagine. But
thank you, Dr. Mondal. In fact, we have limited time.
oh, fine.
So we have another expert in this panel, Dr. Adhikari, with a vast experience in the industry. And as you know, we heard Professor Singhal in the morning that how nutritional qualities can be improved. So I'll request Dr. Adhikari to highlight the processes which can improve the nutritional aspects, especially in the food, using oils and fats. Dr. Adhikari, please. Yes. Okay. You want to go there? No problem.
Thank you, Dr. Tripati. Good afternoon, everyone. How much cooking oil is too much? This is the subject for today's discussion. That means, what should be the quantity of cooking oil that we need for our daily consumption? Only 2 to 3 tablespoons of oil is enough for our daily consumption. An adult should consume 2 to 3 tablespoons of oil, not more than that per day, depending upon one's age, sex, and level of physical activity in order to get essential fatty acids. In his speech in the 119th episode of radio program Man Ki Baat, our Honorable Prime Minister Narendra Modi ji has asked people to cut down on their oil consumption by 10% in a bid to combat India's obesity epidemic. This was also signaling towards 60% import of our edible oils. Cases of obesity have doubled in the past years, but what is even more worrying is that the problem of obesity has increased fourfold, even among children. Excess weight or obesity give rise to many kinds of problems and diseases. Now, what are the dietary recommendations for quantity of oils and fats by global organizations? Let us see. Most of the organizations, including FAO, who recommended intake for total dietary fat, that is visible fat and invisible fat in adults, ranges between 20 to 30% of energy. In India, the recommended dietary guideline of ICMR for the total dietary fat intake is 30% of energy. This means that 30% of the total daily energy intake should come from dietary sources of oils and fats. For example, if an individual consumes 2000 kilocalories of energy per day, then 30% of 2000 kilocalories, that is 600 kilocalories, equivalent to 65 grams, must come from total fat, that is visible and invisible intake. Cereals contain only 2 to 3% of invisible fat. However, their contribution to overall fat intake is significant as they contribute to bulk of our Indian diets. The small amount of invisible fat present in various foods add up also to a substantial level in our daily diet, about 15 grams in rural population and 30 grams among urban, middle income and high income groups. Hence, it is necessary to consider the invisible fat intake while recommending dietary take of visible fat, that is cooking oil. Therefore, 30 to 35 grams visible fat, that is 2 to 3 tablespoons of cooking oil is required for a 2000 kiloliter diet per day. The recommendations for total fat intake are further subdivided into 3 parts for the specific fatty acids, SFA, MOFA, and POFA. First part is the ratio of SFA, MOFA, and POFA, which may vary from 1:1:1 to 1:1.5:1. Second part is the ratio of omega-6 and omega-3 should be in the range of 5 to 10. The third part is the intake of EPA and DHA in the diet should be in the range of, that is restricted to the range of 0.25 to 0.5 grams per day. This can be achieved as per recommendations by including an appropriate amount of fish oil or algal oil as per guidelines of FAO, WHO, and ICMR. For people who like fish, no problem for them, but for people who dislike fish, they have to depend on algal oil, which is not so consumer friendly. Rothamsted Agricultural Research Institute in the UK developed genetically modified camelina seeds, which provides an ideal platform for the sustainable land-based production of high-value omega-3 oil for human nutrition market. The seeds produce an oil containing approximately 10% EPA and 10% DHA respectively. This is a good news for the vegetarians who dislike fish. As a result, in our country also, future attempts should be directed to produce genetically modified new hybrid oil seed, which will represent an ideal platform for the sustainable land-based production of the high-value long-chain omega-3 oils, that is EPA and DHA. Therefore, reduced oil consumption will lower the intake of unhealthy fats, leading to better weight management and reduced risk of obesity, improved metabolic health, and reduced risk of lifestyle diseases. Thank you very much.
Thank you, Dr. Adhikari. You know that in India, another very important oil which is consumed, and our economy, in fact, all economy is based on that oil, is palm oil. A lot of things are happening, and especially the issue of G and MPCD is being discussed several times. We have also one expert here, and I will say chair of the FID 13 of the BIS committee, Dr. Pradosh. So I just request him to, if he can highlight a few things on this aspect, what we can do especially in that area, what is the policy government is adopting in that area.
Palm oil.
Yeah.
I think there will be one separate session where we will discuss more elaborately. Just to point out the things, means there are certain misconception, I'll say, that palm oil is not good for health. And some cases, people are telling that, yes, when the saturated fats are more, then we'll have some issues. These things, the technologist can deal very easily by doing fractionation and then taking the, say, palm olein fraction, which is used in our country in large quantities. And on the other hand, palm stearin fraction, they are using it in solid fats. So these things are well known to all of us. And since we are deficient in vegetable oil production and the whole world goes on economics, and the palm oil is the one of the cheapest oils available in the whole world. So if we have to survive, we have to cater the population of our country, then palm oil import will go on. And we are also trying to produce palm oil in India itself. So this we have to study more, and then we have to very judiciously use the oil for different specific purposes, depending on the fatty acid composition, after the fractionation, what we get.
Thank you, Dr. Chakravarti. Another area which is just because it's a panel discussion, so that's oil is not only which feeds population, but oil is also a source of power right now. Worldwide, biofuels are emerging as well as aviation fuels, especially from the oils which are not for renewable purposes. Several commercial technologies are available. I will just mention few, especially the oils which are called waste sometime. And they are being used worldwide, converted into biofuels. And technologies, even from the palm stearin, aviation fuels are being produced worldwide. Technologies exist, and in India also there are several manufacturers now on this area, biofuels. So oil is, as I said, that it's not only feeding the population, but also a source of power, whether it is a transport fuels or even aviation fuels. And this is mainly based on the circular economy, that nothing is a waste. And how those oils, which are not for other uses, can be converted into biofuels. So I think this is also an emerging area, and industries are coming forward for that. So that's one area, and especially when we talk about the sustainable technology, definitely green technology and how we can minimize the waste, and how, when we say green, means how the CO2 emissions and all those things can be curbed. So these are another areas of research, and especially for industry also who are adopting. So these are my few observations which we have discussed. If you have any question from the audience, we can discuss that also. Yeah, you wanted to say something?
No, I was about to ask you, sir, Ruco is one reused cooking oil. So what is your take on that?
Which one?
Reused cooking oil.
In fact, reused cooking oil being targeted, especially for conversion into biodiesels, and some of the agencies, even one agency in Gujarat also, they are collecting those reused oil, especially from industries. But major issue is, what I feel is the collection of that used oil and how that oil can be collected and converted into biodiesel. So major issue is that, and some NGOs have also started that, but there are some restrictions. Government is also promoting. I think if government can promote or provide some subsidy, so on those collection strategies, so reused oil can be converted into biodiesel, especially. That can happen. But only thing that legislation is there, I think, but only thing that if government can take some initiative for those users and promote, industry can take up. This is my observation, because wherever I have talked to those people who are collecting those oils, they are able to collect few drums, sometimes from one city, maybe 1 ton or 2 ton, like that. After that, conversion is not very difficult into biodiesel, but the only thing is the collection. Just like in minor oil seeds, you know that collection of minor seeds. So similar issues is there in this aspect. Any question from the hall? Yes? Dr. Sibdas, yes.
Good day to each and everyone.
Can you provide mic to him?
Just ask for the views of the audience. Now, I find from the title of this conference, it's supposed to deal with the emerging sustainable process technologies. And in this context, I would like to know the views of the expert panel about the prospect of using membrane technology, particularly cold filtration or micellar filtration under cold condition or below ambient temperature, when you can avoid many of the problems, like the solvent loss, then the color problem due to high temperature process, and the degradation of the organics. I would request the expert panel to have a deliberation on this. Literature is available. I think there are published literature, particularly one of our speakers in the yesterday mentioned about all these things. But I think some vigorous or more persuasive efforts are necessary, and the expert panel considers, I think, necessary action should be suggested, particularly in the national context, when we have shortage of vegetable oil and we are importing.
Yes, sir.
Dr. Chakravarti
Thank you. Sir,
respond.
I was one of the member of the team led by you for this membrane degumming particularly. The major issue was the polymeric membranes are not to be used because of means compatibility with hexane. So that was major issue there. Then we shifted to ceramic membranes. And ceramic membranes, when we go for soybean oil or rice bran oil, where the gums are more, what we have seen is after certain concentration of the gums, it becomes so sticky or viscous, then it is very difficult to get the flux out of the membrane. And so far I know one plant in Belgium, that was Cargill plant, they have tried to do degumming with the membranes, and after a few trials, they have stopped. So right now, there is no commercial membrane degumming plant, at least for oil processing. But fractionation is the area where we can easily use the membrane processes. And in other, I think King Shukda can tell us more. This is one area where we should concentrate as far as membrane processing is concerned, because the major degumming problems were solved by introducing enzymatic degumming, which actually is more easy to adopt and more commercially viable.
Thank you, thank you, Dr. Chakravarti. If you
My question is, since you were talking about the misconception regarding the palm oil, we often see on the packagings no palm oil, and that creates a negative advertisement for the palm oil in the industry. And we all know that if you talk about the yields, you know that if you look into the deforestation part, since the yield for palm oil is highest, it will lead to least deforestation if you compare and you consume any other oil. So, be it from the health angle or be it from the sustainability point of view, we can always go for palm oil. So, what can be done collectively to remove that misconception in the industry?
I think there is a session on this issue, including sustainability, what you are saying. So,
I'll tell you, just to add to that, the session will be conducted by MPOC, and
yeah.
I also attended such sessions earlier. But the thing is, until and unless our local bodies do something for that, it will not be mitigated.
Yeah,
Session is not conducted by MPOC. Definitely there will be other experts. You can discuss and you can raise the issue.
I am there in FSSI panel, scientific panel on oils and fats. We are seriously discussing in this particular topic that no palm oil, making a negative campaign on palm oil.
Yes.
That will be handled.
Government is serious on that. Yeah.
OTI also working on the same platform. So what we have done, we are conducting independent studies in 3 universities. Okay, so we want unbiased output of that particular research, you know. So we are doing study at Kolkata University, at HBTU, and at the Mumbai University, ICT. So we have chosen the research leaders, and they are doing research about 6 to 8 months, and they will come out with their outcomes. So we are taking the steps towards it, and we want to come out with the absolutely scientific and unbiased opinion about it. Okay, so we are taking initiative. Thank you.
Okay, thank you, because we have instruction that session should be closed because time we are not having time to discuss anything more. So thank you very much to all panelists who have cooperated and presented their views. Definitely whatever we have discussed based on the experience they have and the expertise they have. Thank you. Yes, sir.
Thank you to the chair, Professor R.K. Trivedi. Thank you. And also thanks to our... Huh? I couldn't... award ceremony. And also thanks to the esteemed panelists for an enriching session. We now begin the award ceremony for oral and poster presentations. Congratulations in advance to all winners. May I now invite Mr. B.P. Manchanda, President, Oil Technologists Association of India, Eastern Zone, to come onto the dais to just give some award to our oral and poster presentation awardee, please. Congratulations in advance to all winners. Now proceed with the award ceremony for the oral and poster presentation categories. First, technical session 1, oral, Ms. Onnesha Basu. একটু হাততালি হয়ে যাক ওদের জন্য প্লিজ আ বিগ রাউন্ড অফ অ্যাপ্লজ ফর হার মিস বাসু অন্বেষা বাসু 3 Anisha, a great presentation. Next, for technical session 2, Deepshikha Tamili. Deepshikha Tamili. Her ma'am Paromita Bhattacharya, please come here on the stage. She will take the award for Deepshikha Tamili. It's a proud moment surely for her ma'am, isn't it? I think so. Next, technical session 3, it's a poster presentation. Omiya Dhore. Omiya Dhore, please come here. Is it unexpected? Oops, I think this type of sound I hear. Omiya Dhore, please come here on the stage. Where is she? Omiya Dhore. Wow. Omiyo Dhore. Oh. Sorry, not Omiya, it's Omiyo. Omiyo Dhore. Thanks a lot, Mr. Manchanda. Please wait. Another, we will felicitate now our organizing committee members. Please wait once again. Wait. Yeah. We will now felicitate our organizing committee members. First to Dr. Ranjana Das, President to Vice President. Wow. President of OTAI Eastern Zone to Vice President OTAI Eastern Zone, Dr. Ranjana Das. I think she is very much popular. Next, Dr. Ganesh Chandra Sahu. Ganesh Chandra Sahu. Dr. Sahu. Mr. Ajoy Kumar Mishra. to Professor Paromita Bhattacharya. I think Professor Bhattacharya is not here in the auditorium. Professor Paromita Bhattacharya. Next, Sri K. N. Sarkar. K. N. Sarkar. Next, K. N. Sarkar. No. Sri T. K. Guha. T. K. Guha. Shopon Dotto. Shopon Dotto. Dr. Neelam Lohia. Dr. Neelam Lohia, yes. Dr. Shurusri Sengupta. I think Professor Paromita Bhattacharya is now here. Anyway, first Dr. Shurusri Sengupta. Dr. Shurusri Sengupta. Dr. Shurusri Sengupta. Professor Paromita Bhattacharya. Mr. Shomuk Raj Banerjee. Mr. Anubhav Das. Miss Oishwarya Das. She's there. That's great. Oishwarya. Miss Onesha Basu. Miss Rituparna Biswas. And the last one, Mr. Purushottam Gayan. Thanks a lot, Mr. Manchanda. Thanks a lot. Thanks a lot for your cooperation. Thanks a lot. Yeah. Yeah, all about completed. Yeah. Please collect the certificates who just present their papers from our counter. Okay, please collect your certificates. Now we will take a lunch break. It's waiting we are for that announcement. We will meet here again in MPOC session after the break. Please reassemble here by 2 p.m. for the MPOC session. It's now lunch break. Okay, thank you. Secretary OTAI, Western Zone, please come on the dais. Professor Amit Pratap. Professor Amit Pratap, Secretary OTAI, Western Zone. And then Dr. Rajiv Churi, National President OTAI, please join us on the dais. So, please take your chair on the dais. Now on the dais we have Mr. B.P. Manchanda, Professor Amit Pratap, and Dr. Rajiv Churi. Thanks to all of you on the dais. May I request Mr. B.P. Manchanda, President OTAI Eastern Zone, to deliver his welcome address. Mr. Manchanda, please. Just you can use this one. Okay. Come here.
Hello. Good afternoon, everyone. On behalf of OTI, it is my great pleasure to welcome you all to the 80th Annual Convention and International Conference. We are delighted to host our delegates, speakers, and participants from across the country and around the world. The Malaysian palm oil plays a vital role in promoting and developing Malaysian palm oil. Since it is established in 1990, MPOC has been instrumental in advancing the palm oil of industry through strategic marketing and communication efforts that enhance the global image and presence of Malaysian palm oil. Over the next 2 hours, you will have the opportunity to attend a serious, integrable, and engagement MPOC session. Thank you for joining us, and I wish everyone to productive and inspiring conference. Thank you very much.
Thank you, sir. May I kindly invite Professor Amit Pratap, Secretary OTAI Western Zone, to present an overview of the MPOC session.
Very good afternoon to you all, dignitaries on the dais, off the dais. So I must thank first of all the OTAI Eastern Zone and MPOC for hosting the session on the palm oil. Probably this is the single largest oil which is being consumed for the edible applications as well as for the industrial applications. Now there is hardly any food product which is available in the market which does not contain the palm oil. So wherever on the label it is mentioned that this contains the refined oil, probably the answer is this must be the palm oil. More precisely, that is the palmolene. Again, this oil has got the best blend of saturated and unsaturated fatty acids, because of which it is utilized for the purpose of even biofuel, vegetable oil-based lubricants, additives, and of course for the edible applications. So since there are several reasons for which this oil is having certain limitations which is being propagated in the market, probably we must thank again the MPOC for taking the initiative and at least discussing the issues which can be overcome as a part of discussion, because this contains one important factor, that is the beta carotene, which is the precursor for the visual cycle. So some such several issues we expect will be deliberated during the session delivered by the eminent speakers. So looking forward for the fruitful discussion, and thank you all.
Thank you, Professor Protha. From his speech, we just comes to know the application of this different application of palm oil, its limitation, its properties, etc., etc. Thank you, sir, for your insightful remarks. May I now invite Dr. Rajiv Churi, National President, OTAI, to kindly address the gathering. Dr. Churi, please.
Thank you, and good afternoon, everyone, and welcome to this important palm oil session. Yeah. Thank you. You must be come across the various campaigns or maybe the ads propagating no palm oil, or it is basically propagating that it's an inherently unhealthy oil. Is there any fact in it? Anybody is claiming there is no palm oil, what is the scientific basis on it? Anybody has put up this, basically the why we saying there no palm oil? Nothing. If you come across the all various the social media, you get all sorts of experts stating which are the good oils, bad oils, but nothing, just everything hearsay. Nothing, nobody has come out with the concrete or anything, a substantiated proof the palm oil is inherently healthy. As Amit said, almost 1/3 of our oil consumption is a palm oil. Why? Because it's abundantly available, and the output per hectare output is the highest if you compare all other oilseeds, is almost 6 to 7 times or 4 to 7 times of any other oilseeds. So in a way, in the small land parcel or in the land parcel, given the land parcel, palm oil will give the maximum output compared to any other oil. So no palm oil has any scientific base, nothing. In fact, you must have, earlier also, the people came out with the no mustard oil. For information, people may knowing it, US FDA has banned the use of mustard oil because it's supposed to be harmful for the children. They have done some clinical studies, but mostly on the rats. So I'll give you one story which happened with us. There was conference, OTI conference, and we had an invited speaker from US, an Indian origin lady. She gave this speech, her topic was unhealthy oil, and she started with the mustard oil. So she gave the presentation, so we asked and I asked, ki, Madam, ki, what was your sample size? How did you conduct the study? She said, we had a very good sample size. I said, how much? 200 volunteers sample size, okay. And we conducted a study over the period of 2 years. I said, we have another study. We have a sample size 2 million people. And period, 100 years. So she didn't understand my point. I say, my whole of North India consumes mustard oil. You go to Bengal, you go to UP, Haryana, everybody consumes mustard oil. So have you come across any report about the nutritional aspect or the cardiac problems in this region? Are there more? Nothing. So on what basis, I mean, you are giving us, like, don't consume mustard oil. There is no basis in it, actually. So maybe, yes, you have done study rats, but I don't know whether for the people, how it turned out to be. So this is another example. Second example, the people came against the coconut oil, again because of saturation. Now you must be knowing, because of his medium chain triglycerides, people have gone back to the coconut oil, and it is now US and other countries is like a sort of a medicinal oil. So this is, various lobbies are working, maybe they have economic interest, are working against so we can't comment it. So our stand, OTI's stand, is that we have to have a neutral, unbiased study. So what OTI has done, OTI has, they have selected 3 universities, and we have doing a study in Kolkata University, in HBTU, and in the ICT Mumbai. And this is just around a 6 to 8 month study, and this, the researchers will study all the facts for the period of 6 to 8 months. So that is how OTA is the taken study. And as I say, we will not go by any reports or anything or any published data. We will do our own study. That is what OTI is doing it. And also OTI is also, along with the MPOC support, we are organizing various these sort of sessions across the country, and let people come, let them discuss, let them put a point. If you have something against it, please substantiate. That is how our stand, because for us, food security is the main issue. If suppose you ban, say, no palm oil, I don't use palm oil, what will happen? Because majority using palm oil, if there is no palm oil is available, what will happen? There is no oil available, or whatever available, which cooking oil will be at very, very high price, which people are not able to afford it. So just because something like is called advertising, I won't call it word gimmick, but advertising, making a point, no palm oil doesn't hold good, you know. So that's why as our endeavor is that, okay, let's study this, let's become your technologists. So let's study as a technologist point of view, and let's come out of the fact. So we have, as I said, Amit said, and Manchada said, we have a very good speaker lined up. So of course, I won't go in technical details because we have a very, very eminent technical speaker. So I will not go into technical part of it. So again, I declare this session as open, and please enjoy this. And please interact with you. If you have any doubts, please interact, please deliberate, because all the speakers will be here to answer your questions. Thank you. Thank you very much.
Thank you very much. Thank you, sir, Dr. Churi. Actually, his brief explanation for don't consume palm oil to why we should use palm oil, from no to yes, from rejection to revolution. Thank you, sir. Thank you for your presentation. Actually, now I will thank both all the 3 persons, actually. And after ending this inaugural session, you will sit on the dais? No, okay, just take your seat in the auditorium, okay? This is the ending of our short inaugural session. Thanks, all of you. হয়ে যাওয়ার পর মাটি হয়ে যাওয়ার পর ফেলিসিটেশন কি প্রেজেন্টেশনের আগেই করে দিচ্ছিস? আচ্ছা, স্যারকে থাকতে বল একটু। After ending of this short inaugural session, I am now requesting Mr. Roshan Matis, Regional Manager for India, Sri Lanka, Bangladesh, and Nepal, Malaysian Palm Oil Council, to deliver a lecture on Beyond the Kitchen, the real story of Malaysian palm oil. Here is a short bio sketch. Mr. Roshan Matis is the Regional Manager for South Asia at the Malaysian Palm Oil Council. With over 7 years of experience in market development, trade promotion, and stakeholder engagement, he spearheads MPOC's strategic initiatives to strengthen the image and market presence of Malaysian palm oil across South Asia. Based in India, Mr. Roshan works closely with government agencies, industry associations, research institutions, and media partners to promote science-based understanding of palm oil's nutritional, economic, and surely environmental contribution. His efforts focus on fostering evidence-led communication, enhancing regional collaboration, and advancing sustainable growth of the oils and fats sector. We are really eager to hear the story Beyond the Kitchen. Mr. Roshan Matis, please. Mr. Matis, before his presentation, he will be felicitated by Mr. Manchanda. Thank you, Mr. Manchanda. Now you can take your seat in the auditorium. Now, Mr. Matis, podium is yours.
Is there any problem? Should I dim the light? I don't think.
No, it's fine. Okay, so very good afternoon, ladies and gentlemen, distinguished guests, esteemed colleagues. So it's my honor to represent Malaysia and it's my honor to present on behalf of the Malaysian Palm Oil Council. So my presentation today, Beyond the Kitchen, the real story of Malaysian palm oil. So it's a mixture of, what I can say is not only palm oil is being used in kitchens, it's used in many other applications which I'll be speaking in my upcoming slides, as well as the story of Malaysian palm oil from where we started many years ago. Okay, so a short, brief introduction about the Malaysian Palm Oil Council. Just as Mr. Manchanda said, we started our first office in Malaysia in 1990, and our main role is strengthening and promoting Malaysian palm oil as a sustainable palm oil globally. And we also are into enhancing market access, working with industry, stakeholders, government agencies, international organizations to address industry challenges. So these are some of our offices worldwide, wherein we have headquarters in Malaysia and one of our main offices in Mumbai, which is handling the entire South Asia region. So basically we are into driving market development and speaking about the benefits of palm oil and focusing on sustainability aspect as well. So this was a short description about Malaysian Palm Oil Council. So now let's know more about a story of Malaysian palm oil, which many of you might not be knowing. So it all started about 108 years back in Malaysia, where the first oil palm seed was planted in the state of Selangor in the year 1917. And it's been 108 years where through research and R&D, okay, so this oil palm tree has become one of the key agriculture pillars for the economy. And it's obviously supporting millions of livelihoods as well. In terms of food security is one of these important features of it. So my next slide is on oil palm. Just as you can see, oil palm tree, many of you might be knowing, but for some of you might not know. I do speak to many people, many consumers, they think that palm oil comes from a factory by mixing different chemicals. Just in terms of, for a layman, it's just similar to what you see as a coconut tree. Just the height of the tree is less. And the oil palm fruit, it's a perennial crop, and we get fruit about 10 to 12 times a year. So we call it as fresh fruit bunches, FFBs. And each FFB weighs about 25 to 30 kg in weight. And the lifespan of oil palm tree is about an approx average of 20 to 30 years. And it's a perennial crop. As I said, we get fruits all around the year. So it's really important, unlike any other oilseed crops, where we see that it's seasonal. So let's get to know something into the global fats and oil scenario, and also the Indian fats and oil scenario, and why palm oil is dominant into this market, and why it's really important. So Malaysian palm oil, we import to many countries across the globe. But if you see in this, India is the largest importer of Malaysian palm oil for us. So we normally, in volumes, it's million metric tons, MMTs, which we look at. From this, Malaysia produces 19 million metric tons per year, and 3 million metric tons is used domestically in Malaysia. In Malaysia, they consume palm oil, and 16 is exported to all the countries across the globe. So from that, 16 million metric tons, 3 comes to India, which is the largest importer, followed by China and other countries. Just as you can see, the second and third countries are not even half of what we export to India. So I would like to say India is one of those countries which is a dynamic oil changing market, like dynamic markets across the globe, where you can see import duty changes or some kind of changes which happen from time to time. So now the oils and fats situation in 2024. The consumption is about 28 million metric tons, and it's gone up by 4%. This comparison is in comparison to 2023. The production has inched up by 3% to 12 million metric tons, and imports have gone up by gone up to 16.9, which is 4%. But these are the overall oils and fats scenario into this market, in the Indian market. If we talk about a particular palm oil situation in India, so the consumption is about 9.75 million metric tons, and production is 0.37, which has grown by 5.7%. So I'll be speaking more about it in the upcoming slides. You get some information about what I'm speaking about in terms of production. Imports are about 9 million metric tons overall. So I would like to say that Malaysia is one of those players who are exporting palm oil to India. Other players are Indonesia, which is exporting about 4.5 to 5 million metric tons. And second is Malaysia, and followed by Thailand and other Latin America countries, or I can say countries from the US as well. US is into oil palm plantations as well. So Malaysia, out of the 9 million metric tons, we exported about 3.03 million metric tons, a growth by 6.5% as compared to the previous year, 2023. So out of 3.03, mainly India is a matured bulk market, wherein they import, industry players import more of crude and refined oil. So 90% of it is the crude and refined form. There's some error in the presentation. So majorly 90%, as I said, is crude and refined oil, which is imported in India in terms of Malaysian palm oil. For the blue portion, it's palm-based oleochemicals, which is 7%. And palm kernel oil is 3%, which you can see in green color. So for the palm-based oleochemicals, many of you may know that it is used in pharmaceutical medicines, or I can say it's used into the personal care products as well as home cleaning agents. And for palm kernel oil, which is used in soaps, cosmetics, confectionery industries. Okay, so the last two slides, knowing the figures of why palm oil is dominant and why it's imported into this market. So production, if you see in 2020 was 10 million metric tons, and till 2024 it has gone to 12.4 million metric tons. So there's been an increase of about 20% over the last 5 years. Consumption as well has gone up by 23 million metric tons in 2020, and currently in 2024 it's about 28. So that's also up by 20%, and imports also up by 20% if you see, from 14 to 16.9. So even though the production is increasing, there's a consumption increase in India. That's important, food security which we talk about, and that's why important for imports into the country, and Malaysia is one of those countries bridging the gap. So this is the last slide on to knowing the statistics about this industry. What are the other oils which are imported in India other than palm oil? So palm oil is 9 million metric tons in 2024. Soybean is 4 million metric tons, and sunflower is 3.6 million metric tons. And others are rapeseed oil in small quantities. So if you see, 44% of it is domestically produced and 56% is imported oils. From those 56% of imported oils, 53% is palm oil which is imported in India. So that's why palm oil has been an important commodity into this market. So just as I said, palm oil is one of those dominant commodities into this market. And Dr. Churi rightly mentioned, palm oil produces has a very high productivity and better yield as compared to any other edible oils. So it produces about 3.6 tons per hectare as compared to any other seed oils. That's the reason its price is less. It's an inexpensive oil, I would like to say. And inexpensive in the sense, it's just like any other oil. It's a good quality oil. Research has proved it in the past. And it's way beneficial for the farmers as well as consumers, because the price is less as compared to other oils. But unlike from the last 2 years, obviously I would agree, palm oil is getting imported at a premium because of the high demand into the international market, and soybean has been selling at a cheaper rate. And there have been ups and downs in terms of prices, and India is a price sensitive market. Okay, so based on the research from over many decades in Malaysia, Indonesia, India, so this is something which is quite interesting to know. It's resistant to oxidation. The key attributes, it's cholesterol free. Like I speak to many consumers, people think palm oil does contain cholesterol. There are many influencers or many people on social media who do say that palm oil contains cholesterol, but it's a plant-based oil. So any of the plant-based oil is cholesterol free, in fact. It produces less harmful compounds as compared to any other oils. When you look out for deep frying, it has a high smoke point of 235 degrees Celsius. It has a long shelf life. That's the reason why food manufacturers are eager enough to use palm oil in their formulations. It's resistant to spoilage, and it has a powerful antioxidant, vitamin E. Like in recent times, you might have heard about antioxidants, and palm oil does contain vitamin E, tocotrienol. It has an anti-inflammatory function. It's stable at high temperature, and it has a balanced fatty acid content. Now coming to this is really important because saturated fat has been the biggest issue of palm oil in India. People have been targeting that it contains high saturated fat. But some other oils which contain high saturated fat in India have been said as heart healthy. So palm oil is a balance of 50% saturated and 50% unsaturated fat. And ICM or NIN, in their 2024 guidelines, said that palm oil can be made part of a balanced diet because oils and fats are equally important for every person in India. Next, it retains the flavor of the food, that's shiny and smooth texture in your ice creams. Palm oil is used. It contains less oil, it absorbs less oil, in fact. It's non-GMO, less sticky on walls and utensils, and it is trans fat free. So it does not need to go through the process of hydrogenation. It's trans fat free. It has a crispy, crunchy texture. That's why many companies like McDonald's, KFCs, they use palm oil in their cooking. And also it's easily can be blended. Like in Malaysia, I know they use a blend of oils. 90% palm oil and 10% groundnut or something else. So I have spoken to many medical experts over the past, and they said that it's necessary to use a blend of different oils, change and use 2 to 3 oils, rather than just sticking to one oil. So we've spoken a lot about, like you've got to hear a lot about facts about palm oil, what are the global scenarios, and got to know why the price is less, and various other attributes of palm oil. So here I would like to tell you, you start your day with palm oil, you end your day with palm oil. Even though you don't, if you try to reduce palm oil in your cooking, it's not going to like work out. So just as you're using your phone daily from morning to night, you're also using palm oil from morning to night. So this is an interesting story where you wake up in the morning and you grab your brush and that foam which comes out. So palm oil says good morning. Next, gentlemen reach out to the shaving cream and guess who's helping that razor glide. So it's palm oil again. Next, you might have had breakfast in the morning, bread with butter or chocolate spread. So that shiny texture comes to palm oil again. For ladies, you might be using moisturizers, nail polish, and eyeliners, and lipsticks. So there is some kind of palm oil in it. It does not work without palm oil. For many of them who have worn coats today, leather shoes, leather bags, there's some bit of palm oil into that as well, because the shinier, the shine which comes from palm oil. Also, you might go back in the night, your sofa might be waiting for you to come and watch some Netflix. The sofa also does contain palm oil, so you can't live without palm oil. From morning to night, you're going to use palm oil in some way or the other. Okay, so when I said about production, India is into production of palm oil, where it produces 0.37 million metric tons per year out of the 9.75 which is consumed in India. So there are some initiatives taken by the Indian government. And in 2021, there was a national mission on edible oil palm. And there was a financial outlay of 11,000 crores, wherein the government did their research and they understood that this is a cash-rich crop and it can be useful for the food security in the upcoming years. So there's a lot of oil which is imported. Let's get into self-sufficiency and reduce the import dependence. And so India has identified 15 states in India wherein land is suitable for cultivation. And just as in orange, you can see those areas where oil palm plantations are currently going on. In Telangana, Andhra Pradesh is very mature plantations. Karnataka, Tamil Nadu, and northeastern belt where the plantations have just started in some of the states. Also, there are other states where the government has identified land for cultivation. So here, when we talk about cultivation, when it comes to deforestation, the second issue after saturated fat. So deforestation is something which many influencers have been targeting, or many people have been speaking on social media, or something which has been going on in 2016-17, people come out with some press release or a news article. But if I say in Malaysia, we have stopped increasing the plantation of oil palm. And after 2020, we are not cutting down trees or doing anything. So the fact is, from the last 5 years, we are focused on sustainability. And India also, according to my information, I know that there's bio-waste land which is available, which is going for oil palm plantations. So there is no kind of deforestation which is happening in these countries which I have got to know. Okay, so Malaysia is not just a partner engaged in trade. Other than trade, we are also playing an important initiative in supporting India in this oil palm plantations. Just as you can see in the left picture, India has become Malaysia's top palm oil seed buyer. So we have been doing a lot of R&D over many years, and we have been supplying oil seeds to India. Also, Patanjali Group, which is the largest importer of oil palm. Okay, so they have also got into oil palm plantations, wherein they have got 50,000 seeds from one of those states in Malaysia. And they are also planning to open an oil mill, so that it's a benefit for the farmers in 2026 in one of those northeastern states. So these are some of the glimpses wherein we are a government agency and the Ministry of Plantation and Commodities in Malaysia. Our Honorable Minister was invited last year during IVPA, the bottom right picture, and we did have a discussion, B2B matching, B2B session, and understand the industry challenges which industry is facing. And also he was also invited earlier this year for Globe Oil, which is the largest edible oil industry event, to give the key opening remarks as a chief guest. Also, so let's get into something like MPOC initiatives in India and understand more. Just as Dr. Churi said, MPOC and OTI signed an agreement of collaboration earlier this year during the FOIC conference in March and spoke on various palm oil and also tied up on research projects and seminars in India. Also this year, earlier this year, we signed an agreement of collaboration and working with IVPA together in debunking myths about palm oil. There are a lot of misinformation going out from many years that palm oil is not that good for health. But the fact is something different. On the right picture, you can see we've been working with Z Business, Z News over the last 2 years by doing a documentary. And there are various medical experts who have come on the channel and spoken about the palm oil facts. And this has helped to debunk some kind of myths in India. And okay, so these are some of the work which MPOC has done, wherein we provide opportunities for the R&D done by companies to come and so that they can come and showcase their products in India. On the right side, you can see recently we did a nutritionist podcast series with Lima Majan, wherein she debunked myths about palm oil. She spoke the facts. We also worked with Sakshi Lalwani, a famous nutritionist. And on the left corner below, there's Chef Neha, who's a food scientist in India and the only flavorist in India who has spoken advocating for palm oil. Okay, so this is almost the last slide for my presentation. This is a short 2-minute video about what MPOC has been doing over the last 2-3 years and a perspective of the Malaysian palm oil industry. So let's see this. Sound is not coming. Yeah, can't hear it there. Yeah. But the voice is coming here. No. Clear? Their voice is not coming. you can just play this here.
Malaysia stands as a global leader in sustainable palm oil, powering growth and innovation across the oils and fats industry. Under the guidance of the Honorable Minister and MPOC's leadership, Malaysia has been a proactive partner in strengthening India's edible oils ecosystem, advancing trade, sustainability, and shared prosperity.
So how does Malaysia enhance the trade and market access for certified sustainable Malaysian palm oil in accordance with the global sustainable standards?
Well, basically we value about environment, and everything that we do here, we always make sure that sustainability production of our palm oil is in sync with the world requirement.
Through nationwide consumer outreach, media engagement, and industry collaborations, Malaysian palm oil has engaged millions, inspiring healthier choices, debunking myths with science-backed insights, and supporting research and knowledge sharing that strengthen India's oils and fats sector. Together, we celebrate taste, nutrition, and innovation at the heart of every kitchen.
मलेशियन पाम ऑयल एक ऐसा ऑयल है जिसका स्मोक पॉइंट काफी हाई है, तो ये इजीली ब्रेक डाउन नहीं होता है। इसमें काफी बैलेंस्ड मात्रा में सैचुरेटेड और अनसैचुरेटेड फैट्स होते हैं, तो आप भी बना सकते हैं ऐसी ही कुछ इंटरेस्टिंग रेसिपीज पाम ऑयल के ट्विस्ट के साथ।
Today, we reaffirm our shared vision. Malaysia, your trusted partner in nutrition, innovation, and sustainable growth.
So in conclusion, I'd like to say that Malaysian palm oil is a vital, sustainable and more focused towards promoting palm oil benefits and ensuring palm sustainability along with the compliance with the international standards. Thank you for being a patient listener. We're playing the video again.
Malaysia stands as a global leader in sustainable palm oil, powering growth. Malaysia stands as a global leader in sustainable palm oil, powering growth and innovation across the oils and fats industry. Under the guidance of the Honorable Minister and MPOC's leadership, Malaysia has been a proactive partner in strengthening India's edible oils ecosystem, advancing trade, sustainability, and shared prosperity.
So how does Malaysia enhance the trade and market access for certified sustainable Malaysian palm oil in accordance with the global sustainable standards?
Well, basically we value about environment, and everything that we do here, we always make sure that sustainability production of our palm oil is in sync with the world requirement.
Through nationwide consumer outreach, media engagement, and industry collaborations, Malaysian palm oil has engaged millions, inspiring healthier choices, debunking myths with science-backed insights, and supporting research and knowledge sharing that strengthen India's oils and fats sector. Together, we celebrate taste, nutrition, and innovation at the heart of every kitchen.
मलेशियन पाम ऑयल एक ऐसा ऑयल है जिसका स्मोक पॉइंट काफी हाई है, तो ये इजीली ब्रेक डाउन नहीं होता है। इसमें काफी बैलेंस्ड मात्रा में सैचुरेटेड और अनसैचुरेटेड फैट्स होते हैं, तो आप भी बना सकते हैं ऐसी ही कुछ इंटरेस्टिंग रेसिपीज पाम ऑयल के ट्विस्ट के साथ।
Today, we reaffirm our shared vision. Malaysia, your trusted partner in nutrition, innovation, and sustainable growth.
Thank you so much.
Thank you, Mr. Mattis, particularly for your informative and thought-provoking address from inside the kitchen to beyond the kitchen. Thank you very much. Now, a memento will be present to Mr. Matis by Mr. Manchanda. Mr. B.P. Manchanda, please come here again. It's a real problem. Thank you. Mr. Manchanda, please you what here. We now move to the next invited lecture of the session. Our searching for healthy and nutritional food is an endless phenomenon. Dr. Ranjana Das, Associate Professor, Chemical Engineering, Jadavpur University, will now address to the audience on oil palm, golden oil from golden nuggets, highlighting health and nutritional aspects. Dr. Ranjana Das completed her PhD in Chemical Technology from Calcutta University in 2009 and obtained MTech and BTech degree from Calcutta University. She is recipient of 11 national awards and gold medal from CU in 2005. She has 32 research journal publications, 33 book chapters, and 62 conference publications. She is affiliated to Indian Institute of Chemical Engineering, Executive Committee member, Oil Technologists Association of India, Vice President Eastern Zone this time, and Indian Science Congress Association. Her research area is wastewater treatment, solid waste management, membrane technology, nanomaterial synthesis, and application. She will now be felicitated by Mr. Manchanda. Thank you, Mr. Manchanda. You can now take your seat in the auditorium, or as you like, Now, please welcome Dr. Das. Now, microphone is yours.
So welcome you all again for this specially our session on palm oil, which is sponsored by MPOC, our main support for organizing this event. I'm thankful to Mr. Roshan for his contribution and his support in organizing this event so beautifully. And probably you have heard, my expertise area is not palm oil, except palm oil. So I am trying to give you an overview about the nutritional aspect of the palm oil because from our speakers from the morning and Mr. Martis and Dr. Rajiv Churi, they've all highlighted that there are some misconceptions. Even in the panel discussion, we have also heard that there is lots of misconception is there regarding the use of the palm oil. And this palm oil is known to us. Even in the, like in a kitchen, it is not accepted as a cooking oil. Nowadays also, we are relying only on the mustard oil and the rapeseed oil and the sunflower oil. So there are lots of misconceptions about the use of the palm oil, and this particular presentation, I am trying to give a brief aspects, in brief, some specific aspects which can be addressed, which have already been addressed, but they have not industrially still exploited, or some aspect that we can explore. So it is a message for our students also, if they want to work on this particular type of field, so they can fill the gap and they can also give their contribution to fill the gap and to make this palm oil a oil of future. So let's start with the little introduction of the palm oil. Mr. Martis already have covered everything, I suppose, but still as a part of my presentation, I'm just giving you the brief idea. These are the points that I want to cover. Best produced edible oil in the world, and oil palm and palm kernel. These two type oils are there with the name of same, they are sharing the same name of palm. And there is little bit difference of this, obviously, the palm kernel oil and the palm oil. So palm kernel oil, palm oil basically it is from the mesocarp portion, and palm kernel it is from the soft inner part of the seed. And there are some specific features of the palm oil and the palm kernel oil, how they are different. From the picture above, you can see the students basically for there, what is the difference between the palm oil and the palm kernel oil. The first one is from the mesocarp portion. You can see it is already mentioned there with the arrow. And the palm kernel, it is from the seed, inside portion of the seed. And this palm kernel is also having higher percentage of the saturated fatty acid. And these are some of the salient features of the palm oil and palm kernel oil. Probably you also know about this fact. And the present status of this palm kernel oil, as per the Economic Times, Mr. Martis also have covered those parts, that India is now emphasizing on national mission on edible oil, oil palm, that is NMEOP mission, which was introduced in August 2021. And within this scope of this mission, they nearly want to cover about 6 lakh hectares of the land in India to, for the palm cultivation. And major states, those are now involved. Mr. Martis also have involved. He also have presented that, mainly Telangana and Andhra Pradesh. They are sharing about 98% of the country's oil palm production. So these are the little bit of the present status of palm oil in India. And what is the remarkable transition is there, palm oil? Just a statistical report is there. In 2020, the cooking oil used in India was the sunflower, which was about 25%, while in palm oil was only 2%. And the transition in 2024, the figure is, as per the report of Economic Times, it is 37% of consumption. And in 24 to 2030, it is expected to be around 38%. And Times of India report also that India consumes 9 million tons of the palm oil annually. So these statistics obviously giving us the idea that how the importance of the palm oil for the consumption is increasing. That means people are now becoming curious about the use of the palm oil, and they are now becoming a little bit interested that the palm oil can be consumed. Though we know that that Mr. Martin also mentioned that, from when we are just leaving our bed and when we are going to bed, so in between this, in all the tasks, the palm oil is there. But people don't know that. They don't know that, but now they have learned. They are now becoming interested to use the palm oil. So that statistics represent that remarkable. And these are some of the important facts that I have highlighted only. So the other parts are there only from the statistics. The highlighted portion is that it accounts for about 1/3 of the total global edible oil production from only 6% of the total global oilseed harvested area. Now, why it is so important? That means the land requirement and the production, that ratio is representing what? That means how much land is required for production of particular production of the oilseed. So this point is very important. That means land requirement, that the means conception, that deforesting is required for this palm oil cultivation. So answer is no, it is not like that, because the land requirement is much less compared to any other oilseeds. And the per hectare palm oil yield is almost about 5 to 8 times more than any other leading oilseed crops. And Among this important oil, crude palm oil, it's make up to a huge portion, that is 57% of the normally imported edible oils. So these are some of the facts about the palm oil. And here is the distribution again of statistical data is showing that the edible oil consumption in India, where the people are, mostly the people are just consuming this edible oil, this palm oil. And as per the statistics, it shows that in India, in the different region, the consumption pattern is different. It's depending on the availability, it's depending on the affordability, and it also depending on the culinary tradition. So based on that, it is a variation. And the mission, palm oil mission, its aim is that there should be the parity of the use of the palm oil all over the India. So that's the mission of the that Indian government has taken. And these are the misconception that I have highlighted in red, that large-scale monoculture plantation, it can negatively impact the biodiversity and groundwater level. And this misconception of surrounding palm oil is that the sustainable palm oil is a greenwashing campaign. So this campaign is against palm oil. That is, it's called the greenwashing campaign, because they think that this, whenever you are going for the palm oil cultivation, you are moving towards the deforestation approach. But it's not like that. I've already mentioned that per hectare production, that means the land requirement for the production of the palm oil is much less compared to the any other oils. And some other factors are also there. The output to input energy level for the palm oil, it's very good, quite good. And per hectare requirement, it's also much less. And the sustainability issue, since the misconception is there, that means you need more land and deforestation is there, or it is a greenwash campaign. So obviously, from a perspective of an industry, they are now trying to consider about and for the multi-stakeholder governance. And there are two partners of this like RSPO, that means this Roundtable on Sustainable Palm Oil. And those partners are mainly like Malaysian Sustainable Palm Oil and Indonesian Sustainable Palm Oil. So these two are government bodies who are controlling, who are taking care of these issues. That means so that the palm oil cultivation or palm oil is not becoming any is not a cause of any type of the environmental issues or not hampering the environmental aspects. These are some of the guidelines. Almost for the Malaysian palm oil as well as from the Indonesian palm oil side. So all the points are almost similar, and you can say only the terminologies there are a little bit different. And in case of Malaysian, they are considering for the best practices. This term is very small, but it is in depth. So best practices they are emphasizing on, and in case of Indonesian, they are mainly considering for the sustainable business development. So these two terms are very important from their guideline. And these are the different national missions to boost edible oil production. The first one, we have already mentioned, that national mission on edible oil, that is palm oil. And the second one is also there, that is technology mission on oilseed and pulses. The third one is oil palm development program. This is integrated scheme of oilseed, pulses, oil palm and maize. And another mission is there, that is national mission on oilseed and oil palm. So all these missions, their objective or their planning is almost similar. Okay, they are all concerned to promote the palm oil, but without compromising any other issues, mainly the environmental issues. So there is different other these are the different aspects for the, that means the government policies are there for this palm oil, promoting the palm oil. And Mr. Martis have mentioned that there are lots of uses of the palm oil, but we don't know that. So that's why it's called the complexity of the palm oil market. That means we are consuming the palm oil, but we don't know where we are consuming the palm oil. So palm oil is coming in the market with a different name. Okay, that means the palm oil market is very complex. Like with the name of palm oil, the component is there, then you can identify, yes, the palm oil is there, like cetyl palmitate. So the name is palm there. But if we considering only about the like sodium carnallate, then no, the name of palm oil is not there. So we are consuming the palm oil in different aspects, like Mr. Martis also mentioned that from the lip balm to the hair oil, even in the sofa, on the sofa. So leather bags, we are using palm oil everywhere. So the using pattern of the palm oil is very, very complex. Now, this palm oil nutritional aspect. So we have the misconception that palm oil is not good. But where is the problem? Why we are not interested to consume the palm oil? As per the fatty acid composition, that is very important to assess the quality of the of any of the oil. The saturated fatty acid, its percentage is about 48%, whereas the MUFA, it is about 40%. The PUFA, that is polyunsaturated fatty acid, is about 12%. And there is some non-glyceride fractions, that is 1.2%. And there are lots of the antioxidants also, like tocopherol, that is the bioactive components, tocotrienol, and carotenoids also there in the palm oil. Now, where is the problem? The problem is that normally it is mentioned, but it is guided by the WHO that there must be a particular level of particular proportion to maintain for a good quality oil. And what is that? The ratio of the PUFA to MUFA to saturated fatty acid. So they have provided a guideline. Whenever your oil is maintaining that particular proportion, that means it is a good oil. Now, since in the palm oil, the percentage of the SFA, that is the saturated fatty acid, is a little bit high, so we are thinking from the guideline that, no, it's not good. But there is mainly, we have to understand why we are telling so, that if the saturated percentage is high, why it is bad. If the saturated percentage is high, then what will happen? Its appearance, it is normally like having solid content is high at the room temperature. That's the problem, obviously. But how it is affecting the nutrition? Now, when the oil we are consuming, what is the fate of the oil? Suppose we are taking the oil, with the food, is a frying oil or it's any other oil. So what is the fate of this oil in our body? So it is directly the oil or the fat portion is going to the mixing with the pancreatic juice, it's going to the intestine, where it's getting hydrolyzed. It is now assimilated with blood, and with the blood it is going to the liver, where the liver is again controlling, and the amount of the fatty acid is going there. In between this path, the cholesterol is there. In our body, the cholesterol is there. Now you'll consider the cholesterol bad. No, cholesterol is not bad. But whenever this cholesterol is combined with the fatty acid, then the ester of that particular cholesterol ester with the fatty acid, that is bad. So if it is a saturated fatty acid, then what will happen? This saturated fatty acid will combine with cholesterol, and it will cause that particular fatty acid cholesterol ester. Now that cholesterol ester, when it's going to the liver, now liver is telling us that you break this again. So it's breaking down again the saturated fatty acid and the cholesterol ester. If the control of the liver is not there, that means if the excess of the cholesterol ester is there, now it is going to the veins, and it is causing the deposition. That we call generally the cholesterol deposition. So cholesterol is there, but that is not depositing. There is a complex function on the cholesterol that causing mainly the deposition of the cholesterol. Now the fatty acid is responsible for that because the fatty acid is combining with the cholesterol and is causing the deposition. That much we know. Now, how to control this combination? Now, in palm oil, if we consider about the triglyceride composition, these 3 combinations are possible. Okay, 4 combinations are possible. That is tripalmitin. All the portions are palmitic acid, 1, 2, 3. It may be like 2 positions are with saturated fatty acid, palmitic acid. 1 is a monounsaturated fatty acid, oleic acid. Now 2 positions with oleic acid, 1 position is palmitic acid, and 3 olein. Now 3 olein portion, that is safe. That is mainly the cooking oil we are using. Now the PPP, that means when the 3 positions are the palmitic acid. Now what will happen? In our body, the enzyme system is such that they will release the palmitic acid from the 1 and 3 position. That means the first P and third P, it is now released. And they are now available for the reaction with the cholesterol. So, whenever we are trying to consume the palm oil, we have to check that. So, what type of the triglyceride we should take? It may be reached with palmitic acid. That's not an issue. But it should be such that whenever it is going to our body and body enzyme is acting on that particular type of triglyceride, the fatty acid portion is not released. Where is the answer? The answer is that if we can trap the palmitic acid at the 2 position, because 1 and 3 position will be released and body enzyme will act that way. So if we can trap the palmitic acid at the 2 position, then there is an answer. It is in the body, we are consuming the palm oil, but it is not releasing or it is not causing any type of the cholesterol deposition, it is not acting with the cholesterol, and it is in our body, but we are not suffering that cholesterol issue. That means cholesterol deposition issue. So the palm oil is not bad, but we have to modify the palm oil, that means the fatty acid composition. We have to check, or we have to manipulate, or we have to tailor the triglyceride composition so that the palmitic acid is there, but it is not causing any other issues, health issues. So the palm oil is not bad, but we have to just manipulate, we have to tailor some product based on the palm oil so that we can easily consume without any health issues. So that very important, that part that I explained, that I have mentioned, highlighted there only with one line. The significant amount of the saturated acid is there at the 2 position of the triglycerides. We have to trap the palmitic acid at the 2 position, not only for the palm oil also, but any other saturated fats. That means saturated fatty acid rich triglyceride. If we design the triglyceride in such a way, it will be at the 2 position, then it is safe for consumption. So that's obviously a good idea, that any type of these saturated fatty acid product can be tailored so that it is health issues is little bit controlled and we are not suffering from any other type of disease. So that part, I've already mentioned that the cholesterol deposition, that is the myth of the palm oil, that it is not good. And I've explained all these things. And how to do that? What are the approaches? The approaches are already known to us. Whoever just working in the industry or the research scholars and the students, they are just studying about the palm oil. The answer is in your hand. Only you have to execute. What are the approaches? The blending is there, a very good answer of consuming the palm oil. Fractionation is there, and along with the interesterification and the combination of these techniques. Now for a good triglyceride composition, what we can do, how we can tailor by combination of all these process. There is one also the process that is hydrogenation, but I'm not covering this hydrogenation part because hydrogenation, though it is specifically controlled, but sometime there may be some association of the trans fatty acid which is at all not desired. So the researchers have to concentrate on the combination of all these three processes like blending, fractionation, and interesterification. And you know that Dr. Churi and Mr. Martis, they also have mentioned, and also in the first during the panel discussion section, sir also mentioned that palm oil, it is not a problem. Okay, palm oil is not a problem because it is unsaturated, that is MUFA rich. So the problem is with the palm stearin, that means the saturated fatty acid rich portion. So that's why we have highlighted that if we want to improve the consumption of the palm oil, we have to concentrate about the application of the palm stearin part in the different approaches of using that palm stearin for different products. So if we can improve that part, that means we can improve the application potential of the palm stearin, then we can get the answer how to improve the consumption of the palm oil. So palm stearin I have highlighted, and which is having a limited use because of this high melting point and the high saturated fatty acid content. And there are different approaches of using the palm stearin. The first one, that mainly the fractionation of the palm stearin again to the high melting palm stearin fraction and the low melting palm stearin fraction. That means the stearin part again have to just fraction it. It may be either by dry fractionation process or either by solvent fractionation process. So different approaches are there. Probably my time is almost close. So already that fractionation step is there. So with the fractionation process, we can further get these two fractions. And there is a little bit data about this fractionation process, how we can get how the slip melting point is changing with these different type of fractions. And here the temperature is mentioned because I'm just presenting here for the solvent fractionation process at the different temperatures. And LMPA stands for the low melting palm stearin, and HMPA stands for high melting palm stearin. And this paper is already published, so it is not a new one. And these are the different type of the bioactive components present in those two fractions. For this, not only I'm mentioning for the temperature at 15 degree centigrade and for 30 degree centigrade. And here you can see that in case of the high palm mid fractions, normally the bioactive components are less compared to the LMPS. So these are the different type of bioactive profile for these two fractions. And here's the antioxidant data. It is also been published, and where we can see the dry fractionated, that LMPS, it is giving better result compared to these dry fractionated HMPS, and different solvent aspects that also been mentioned. And this is again, whenever we are using this LMPS for cooking preparation, cookies we have prepared, and that cookies have been just assessed for the antioxidant properties, that means for their stability. So we are getting this type of result in terms of DPPH scavenging activity. So obviously it is also telling us that how this property have been improved by the fractionation process, and how it is been, that means the cookies with this type of palm oil fractions, it is also good to consume. This is also the CBS that sir also have mentioned, that CBS preparation, it can be used. So LMPS is binary blending, that with the sal-olin, It is a good combination and it's giving very good slip melting point. So it is good suitable for the CBS preparation. And the ternary product combination is also there. That is ISO. ISO means isopropanol extracted LMPS with the shal stearin and kokum. That is also giving a good combination that for the CBS preparation. That is cocoa butter substitute preparation. And this is also the properties of the super palm stearin. That means the hard palm stearin fractions. And if we consider about the hardness, then you can see the hardness for the palm oil and the blend is also have improved. And in terms of the fatty acid, that is oleic acid percentage is almost the same. And the room temperature, obviously, it's also improved the hardness value. This is also published from our end. And the structured fat that I was talking about, that means the 2 position is only the palmitic, and 1 and 3 position is with the olein or any other MUFA. So that is nutritionally very good structured fat or fat-based nutraceutical. And this particular beta-palmitoleiin, it is mainly infant food formulation it is used. And the preparation method is basically nothing but the fractionation followed by interesterification. And specific interesterification, that is enzymatic specific interesterification is there to produce this from any type to produce this valuable component. The steps that I have mentioned, first we go for the fractionation, then enzymatic interesterification, and also oleogel preparation. It is also an approach to get this type of tailored fat. And probably you should consider where is the new things. Ranjana is telling about what is the new thing. The new thing is that we are doing this using the enzymatic membrane reactor. So we are not doing this only in the beaker as a batch mode, but we are trying to do this in the so that it can be done continuous process using the enzymatic reactor. So for this enzymatic reactor we have done, why? Because we want to make it a continuous process. We want to make it a continuous process. We want to control, that means the reproducibility. We want to get the reproducibility of the study, because whenever we are doing this in a batch, the product variation will be there, product quality variation will be there. So we want to make it a reactor which is a control, which will work in a controlled environment, which will be a continuous one, and it will be AI driven. That means the automated control will be there. That's our objective. So that's the new thing. I suppose that we are concentrating about that total automation of this enzymatic process of getting these structured fat products. So there I am just working because I am the expert of the membrane separation process basically, and my part is basically to develop different type of the membrane system or the reactor design so that the process can be, a batch process can be converted to a continuous process. So this is a setup that I have just mentioned. And this is a batch mode, obviously. The middle portion, you can see it is nitrogen environment is totally maintained during the process, and ultrafiltration membrane cell is there. And this ultrafiltration membrane cell, the process is going on, and this membrane is coated with the enzyme. And ultimately, we are getting the interestified fat products. This is another approach. This one, that one, the first one was the batch mode. It was done in batch mode. But this one, it is a continuous mode where we are not using that type of the batch cell, but here we are using a cross-flow membrane unit. The cross-flow membrane unit is there where the reaction is going on in a reactor and the separation process is going on in the cross-flow unit. Separation of what? Separation of those enzymes, if they are leaching out of the from the process, they are now separated with the ultrafiltration process, and we are collecting the retentate for the improvement of the quality, and after some process this is collected. And this is, I'm showing, this is our patented reactor system. We have developed this in our lab. This is called the rotating disc membrane module. This particular membrane module, it's designed with an aim to overcome the main problem of the membrane separation process, that is the fouling. So whenever you have learned about the membrane, the term is always there, membrane fouling. Everybody asks, we are using the membrane, what is the cost of the membrane? Yeah, the cost of the membrane is very, very high. As I mentioned that, polymeric membrane is also not good because it's causing too much concentrated, it cannot deal with too much concentrated feed. So the fouling is the main problem in the membrane separation process. And that particular design, this design can overcome the issue of the fouling. Where is the answer? The answer is there, only you can see the membrane module on rotating device. Here, the membrane itself is rotating. It is not a stagnant one. The membrane is rotating continuously. It's providing an extra shear on the feed so that no fouling is there. All the molecules, when trying to lodge on the membrane surface, that is automatically swipe away from the membrane surface by this motion of this membrane. So there lies the beauty of this rotating disc membrane reactor. And though since the membrane is rotating itself, so the chance of getting the enzyme separated from the membrane surface, which is lodging on the membrane surface, that probability is also getting reduced because upper feed is only rotating, but the in membrane, it is, that means like the stirrer, when it's stirring, they may contact with the membrane surface. They may damage the membrane surface, but when membrane is rotating, it is not going away. So enzyme is there. It is properly like impregnated there, but the feed is moving, so the probability of fouling is much less. That is our indigenously designed, and it has already been patented. So that approach we are using, that particular type of the membrane reactor we are using for this enzymatic process. And okay, so I'm skipping this part because you all know that different type of micronutrients are there, so which is also helping this process. And there are several aspects. So in a nutshell, just a minute. Mainly, palm oil is a not problem. In a nutshell, we can say that palm oil is not bad. We have to explore the new applications of the palm oil. We have to design different type of food products, which or we have to design different industrial, like technological advancement is required to make this palm oil more acceptable to the people. So with this message, I want to conclude that let's think out of this nutshell and explore more about the palm oil to promote the palm oil. Thank you for your patience hearing and giving me the opportunity to present here, whether I don't know whether I'm justified this proper session or not, but still, thank you everyone.
Thank you, Dr. Das. Actually, when we are talking about cooking oil, naturally, we should know how it used in our digestive system. We just hear here from Dr. Das, from chemical engineering to human physiology. Thanks a lot, Dr. Das, for your excellent presentation. Now, we will just hand over a memento from Mr. B.P. Manchanda, President OTAI-EZ, to Vice President OTAI-EZ, Dr. Das. Mr. Manchanda, please. It's really hectic for you. Nutritional and structural advantages of oil palm for the preparation of trans-free product. May I request Dr. Shunjit Kanjilal, Senior Principal Scientist, CSIR IICT Hyderabad, India, to deliver his lecture on his topic. And it's a short bio sketch We are pleased to introduce Dr. Kanjilal, Senior Principal Scientist in the Department of Oils, Lipid Science and Technology at CSIR IICT Hyderabad, with over 30 years of research experience in oils, fats, oleochemicals, and lipid biochemistry.
Introduced earlier, so give me 5 minutes extra, I can speak.
Sure. Okay. Actually, he wants another 5 minutes extra just to escape his biosketch. Okay. First of all, we will felicitate him, and he will be felicitated by Mr. Manchanda. Thank you, Mr. Manchanda and Dr. Kanjilal. Thank you. Dr. Kanjilal, now microphone is yours.
So, good afternoon, everybody. By the time I load, somebody should come forward and load it. So, I've been introduced to this once again. I don't want it to repeat further. I'll be talking on nutritional and structural advantages of oil palm for the preparation of trans-free product. 1 second, in Kolkata. Next one. So, outreach of the social media is immense compared to your print media or electronic media, because there are people sitting there in print media, electronic media to authenticate whatever they're speaking. But there is nobody in social media. It is completely anonymous in nature, and it reaches fast like anything. So if you want to say anything bad about anything, then you can just use social media. That is exactly as happened in case of palm oil. Whatever misconception and other things are happening, it has happened only after the advent of social media. So I will be talking on the nutritional and structural advantages of oil palm for the preparation of trans-free product. I thank you, Oil Technology Association of Southern Zone, to give me this opportunity, and also thankful to MPOC. So, outline of my presentation about how structural and nutritional advantages, facts about debunks the myths associated with the consumption of palm oil. Then I will speak about regulation of trans fat, both by WHO and FSSAI, and what is the role of palm oil in the mitigation of trans fat, then application, then advantage. This is the overall outline of my presentation. So coming to the myths, all this misconception and false narrative about palm oil and linking it to the consumption of this particular oil to several diet-related chronic diseases is happening for the last maybe a decade, only after the advent of social media. All the false narrative castigating palm oil is dangerous oil, toxic oil, linking it to all the root cause of death from cardiovascular disease, and sometimes even it has been equated to as bad as combined effect of smoking and drinking. You can see one such message has been pasted here from the social media. So all these things, false narrative has got no scientific evidence, and all these things lead to the perception among consumer that palm oil has adverse health effects due to its high level of saturated fatty acids. So let us go through some of the facts partly covered by my previous two speakers. So of course, palm oil contains 40 to 40% palmitic acid. Is that palmitic acid so bad for health? See, palmitic acid is synthesized endogenously in our body. It is an important component of our cell membrane. Transport lipid and many enzymes play a role only after palmitolation. And another interesting thing I want to just speak to you, it is very important for growth and development of fetus, and this is the reason almost all milk, animal milk, whether it's mother's milk and animal milk, contain good amount of palm oil given here. So human milk contains 20 to 24% palmitic acid, cow milk also contains 30 to 32% palmitic acid, buffalo milk also 32 to 40% palmitic acid. So palmitic acid is there. So it shows the role of palmitic acid in the brain as well as fetal growth. Whether it is human being or animal, it is applicable to everywhere. Now, okay, there is a relation between hypercholesterolemic with the saturated fatty acid, but such link depends on the chain length of the fatty acid. So as far as the data provided by WHO, myristic acid is the most hypercholesterolemic, followed by palmitic, then lauric. And stearic acid is considered neutral because it is excreted out of our system. So as per a study conducted at National Nutrition in 1995, wherein the authors compared the consumption of palm oil with groundnut oil and found that it has a comparable effects on serum lipids and platelet aggregation in healthy Indian subjects. So it is a human clinical trial, not a rat study. China also conducted another study wherein the palm oil consumption showed that there is no appreciable effect on CVD risk factors in healthy young adults. What is more important is the third one, which is a meta-analysis of several human clinical trials conducted from 1975 to 2018 with total subject of 533, which showed that compared to other vegetable oils such as sunflower oil, some studies are against sunflower oil, some are on groundnut oil, some are on soya, canola, compared to palm oil consumption did not alter total cholesterol, HDL cholesterol, LDL cholesterol, triglycerides, or any other risk factor associated with cardiovascular disease. So there is no significant impact of palm oil consumption on pro-inflammatory markers and conventional risk factor for CVD. So if I go to structural advantage of palm oil, it's partly covered my previous speaker. You should understand first what happens whenever you eat fatty food. So fat metabolism means fat digestion and fat transport. There are three digestive enzymes like lingual lipase present in the saliva, gastric in the gastrointestinal stomach, and the pancreatic lipase in the small intestine. All these three lipases act on oils and fats whenever you eat any healthy food. Now all these three lipases are 1,3 specific. If you look at the right side portion of the box, you can see nature also knows. Nature knows what to be placed where. So nature always includes essential fatty acids and polyunsaturated fatty acid SN2 position, keeping SN1 and 3 predominantly for saturated fatty acids or fatty acids which are not required by our body or our body can synthesize it. So SN2 position fatty acids are those fatty acids which our body cannot produce it. Nature knows the role of the 3 lipase phase around system. Accordingly, they design the subject triglyceride. And it is a well-known fact that absorption of fatty acid at SN2 position is significantly more than the fatty acids which are released by the digestive enzyme from 1 and 3 position. Now, if you look in palm oil, palmitic acid is predominantly present in SN1-3 position, 87%, only 13% in the 1 and 3 position. So this has actually resulted in a paradigm shift in our thinking, linking saturated fatty acid with cardiovascular disease. There are 3 things. It is not only the chain length, but also position is very important for it to link it to the all these diet-related chronic diseases, because in palm oil, palmitic acid is more, no doubt, but most of this palmitic acid is at SN1-3 position. So it is very important. So some nutritional facts already covered. So I just want to mention that there are many vegetable oil-based nutraceuticals. Among the vitamin E, tocopherol is important thing, which is there almost every oil. What is important is that vitamin E is a combination of 8 fat-soluble components, 4 tocopherols and 4 tocotrienols. Almost all oils are rich in tocopherols, but only 3 oils which contain tocotrienol also along with tocopherol, and these 3 oils are palm, mustard, and rice bran oil. So it is contain almost 600 to 700 ppm of tocols, combinedly called tocopherols and tocotrienols. It also contains a fat-soluble antioxidant called a Q10 enzyme. So this has got many health benefits. I'm not going through this once again. So let us see what is the role of palm oil in the mitigation of trans fat. First of all, I should explain to you how the trans fat generated and what are the different types. What exactly is trans and cis? Because if all of you are from organic chemistry background, you can understand cis means it is a 2 hydrogen oriented at the same direction. Trans means 2 hydrogens oriented in the opposite direction. It has a profound effect in the molecular geometry. If you look at the melting point of stearic acid, which is saturated, you have melting point 69.3 degree, because all the molecules are closely packed to one another. Moment you insert a double bond, so intermolecular distance increases. So if you introduce a cis double bond, the intermolecular distance becomes so much the melting point falls to 13.5 degrees centigrade. So just see how much important is double bond and its role to the melting point. Trans is more like cis. Its molecular pattern is almost like cis. So its melting point is in between, 45 degree centigrade. So trans fatty acids are two types, ruminant trans fat and industrial trans fat. Ruminant trans fats are naturally present in animal and milk and dairy products and produced by the biohydrogenation of unsaturated fatty acid by the microorganism present in the rumen. So predominantly bovine milk fat, it contains around 3 to 5% of trans fat, which is naturally present in milk-based product. Industrial trans fat, on the other hand, are unnatural, man-made. It happens during partial hydrogenation, mainly for the preparation of vanaspati. It ranges from 25 to 60% based on the degree of hydrogenation, the type of oil chosen for the preparation of vanaspati. Another way of, actually another chance of production of TFA industrially is during refining, especially during deaeration, but it never go beyond 1.5%. It's very, very low. Now you tell me what exactly hydrogenation, why the trans fat is generated. We don't want trans fat, we want saturated fat. So we want to convert liquid oil to solid fat by the addition of hydrogen over double bond. That is usually carried by nickel catalyst in the pressure of hydrogen. Unfortunately, during the reaction, due to the presence of nickel catalyst, parallelly another reaction happens. That is not desirable, that is isomerization. So in the isomerization, both geometrical isomerization and positional isomerization happens. Geometrical isomerization means when the configuration changes from cis to trans. And positional isomerization when the double bond jumps from one position to other, resulting in a series of trans isomers. Like this, if you see here as an example, I put oleic acid. If you want to hydrogenate, your purpose is to produce only stearic acid. But what happens, it produces eleidic acid, which is trans isomer of oleic, and also a series of cis and trans olefinic mixture. These are positional isomers. These are side reactions. So if you can see from oleic acid, there are 12 isomers possible from oleic acid, theoretically, and there are 4 isomers from linoleic acid, and almost 7 trans isomers from linolenic acid. If you look at the chromatogram that has been taken from the WHO Global Protocol, if you see the shaded part is the part where you can see trans fat. If you are not very selective, if you are not using correct method, if you are not using 100-meter length column, you will be underreporting the trans fat. All the results will be wrong. So this is how it should be done. So why such regulation of trans fat? So industrial trans fat unhealthy, increased risk factor associated with diet-based chronic diseases. That's why the regulation. The WHO regulations are set up in 2018. They have come out with the Reflex Action Framework and outlines 6 strategic action areas for global elimination of trans fat. The recommendation is such that a country must have 2 best practice policies. First one is the mandatory limit of 2% of, that means 2 gram of industry-produced trans fat per 100 gram of total fat, or complete ban on production and use of a partially hydrogenated oil. In 2023, WHO created a trans fat elimination technical advisory group to go through the country application and identify them as trans-free nation. I am basically a member of this advisory board. Almost 14 people has been identified by WHO till today as trans-free nation. If you look at this profile, you see from 2004 to 2008, there is only one country with trans fat policies, that is Denmark. After they slowly, one by one, each country started understanding the importance of this regulation. In 2018, around 11 countries registered has the best practice policies when this Reflex Action Framework by WHO was launched. Now, by 2025, these best practice policies will cover almost 50% of the global population. So coming to FSSAI regulation, we know a partially hydrogenated oil, nothing but vanaspati, is poor man's ghee. Western word is called clarified butter. Purpose is to increase the oxidative stability and increase shelf life, which is ideal for deep frying. Till 2018, absolutely no regulation in India, no limit. The best practice TFA regulation started from 2009, when FSSAI passed regulation limiting trans fat to 10%. Then from 10%, it was brought down to 5% by 2012 and 3% by 2021. Finally, from 1st January 2022, it was said and not more than 2%. So giving ample time to Vanaspati industry to adapt to this new regulation and look for alternative to PHO. See, India is a big country, so many industries. FSSAI doesn't want to impose a regulation suddenly. So it has taken nearly 15 years to come out with this regulation. FSSAI also did another thing, They have introduced both palm oil and palm stearin as permitted oils and fats to be used for the preparation of vanaspati. Earlier it was not there. In 2018, our panel has introduced these two fatty acids. So this is the regulation, same like WHO, I'm not going to it. But one thing is, if the trans fat content is less than 1% by weight of total fat in any food product, then the manufacturer has the liberty or tell that it is a trans-free product. Application in food sector. So first, trans-free vanaspati. It is very difficult for the FBOs to stick to the regulation unless they use this palm oil or palm stearin. Because since then, this importance, because their consistency is very close to palm oil. Since then, importance of palm oil has grown rapidly. So what they are doing initially, they started physical blending of palm oil and palm stearin. Then look for that any other option, because physical blending is not really allowed, permitted. Enzymatic intensification also permitted, that can be adopted. Alternate option for the preparation of trans-free vanaspati, though it is partly costly alternative. So you can also take palm stearin and intensified with rice bran oil, sunflower oil, soybean oil, so that trans-free product will have adequate quantity of essential fatty acids. Another option was, last option, actually many industries are doing it now, total hydrogenation. So if you do total hydrogenation of any vegetable oil, you will end up with palmitic and stearic acid. After that, you can intensify this fat with any other PUFA-rich oil like rice bran oil, sunflower oil, and soybean oil. This is how trans-free vanaspati palm oil options. So in 2018, I have collected one sample from the market. Those days, they used to say intensified, but it turns out that it is a physical blend. You can see top one, I don't know, it's not coming anyway. First one, vanaspati, first figure light, you can see three prominent peak. First peak is palmitic, oleic, then palmitic, oleic, palmitic, and tripalmitin. So tripalmitin as such is not there in palm oil. That is visible. You can see the second chromatogram where you can see only two triglyceride peak. And the palm stearin has got both these triglycerides and a prominent tripalmitin peak. So this looks like this is a physical blend of palm stearin with palm oil. So what exactly is done in the industry is that they take refined bleached deodorized palm oil, they do fractionation, they separate the solid fraction as palm stearin, liquid fraction as palm oil, then mix this thing in such a way that it reaches a melting point very close to the vanaspatis. That's how those days, 2018, people used to do trans-free vanaspati product available in the market, but now it has changed. They are opting for alternate technology. So margarine is another product where it has palm oil has a role. I just give an example of eutectic mixture of 63% palm oil, 7% palm stearin, and 30% palm kernel oil is used in the formulation of trans-free margarines. As you know, as per FSA regulation of margarine, the fat content should not less than 80%, water content should be 12 to 16%, slick melting point to be 31 to 37 degrees. So palm oil and palm stearin and palm kernel oil giving an eutectic mixture meet the regulation meant for trans-free margarine. Multi-source edible oil, already mentioned that this oil is a combination of equal amount of saturated and unsaturated fatty acids, almost 50-50. If you take palm oil, you look at the left-hand table where you can see fatty acid composition of palm oil. where saturated fatty acid is almost 50%, MUFA 39, PUFA 9.9. If you look at the next column, which is soybean oil, where you have saturated fatty acid 17.4, MUFA 26.7, and PUFA is 55.9. Now, if you take 50-50 blend of palm oil and soybean oil, you reached almost the ratio which is suggested by WHO and ICMR, which is SAFA, MUFA, PUFA will be 1:1.5:1. Even omega-6 to omega-3 ratio also pretty close to recommendation 5:10. Confectionery fat, you know cocoa butter, characterized by, chocolate, moment you put in your mouth, it just melts because it is liquid at our body temperature, but solid at 25 degrees centigrade. It has got a very sharp melting behavior, and it's an interesting properties like contraction and solidification, which is important in chocolate demolding, and medium for dispersion of other constituents. These are the properties of cocoa butter. So all these properties are due to the presence of three triglyceride, not symmetrical, unsymmetrical triglyceride of the type SUS, saturated, unsaturated. These together constitute nearly 90%. So because of the high cost, increase in demand, shortage in supply, cocoa butter alternatives are coming into the market. There are three types: CBE, CBR, and CBS. So I will just not go through much. You can see cocoa butter equivalent, palm oil, palm fraction, palm stearin. These are some of the non-lauric fats which does not alter the properties of CB in mixture. They have similar fatty acid composition and similar triglyceride profile of like cocoa butter. CBR, on the other hand, they have similar fatty acid composition but completely different triglyceride structure. And CBS, basically lauric fat like coconut oil, palm kernel oil, MCT. These are suitable for 100% substitution. If you look at the down table, you can see percentage of triglyceride, mainly POP, POS, and SOS in cocoa butter: 17.6, 41.8, 28.1. This is the cocoa butter. Now the red line one, which is rich in POP, which are palmolene, palm stearin, palm meat fraction, hard palm meat fraction, fulvara. And right side is black underline is rich in SOS, so which are rich in basically SOS rich and also contains substantial amount of POS. So if you combine this, so palmitic oleic, palmolene, palm stearin, palm meat fraction can be used in combination with shea, kokum, and mango kernel, mango stearin, salt stearin at a specific to give cocoa butter equivalent with melting properties very similar to cocoa butter. So it can replace completely 100% cocoa butter. Or alternatively, these things can be used as cocoa butter equivalent at 5% level as per the regulation. So like this, you have application of palm oil, right from ice cream to frying oil, multi-source edible oil, trans-free product, trans-free vanaspati, chocolate, etc. So take a message, or I want to conclude. Many people say that it has got a high yield per hectare yield, nearly 5 to 10 times to other edible oil. It has an excellent smoke point, fairly good oxidative stability, and hence ideal for deep frying. Absolutely no flavor, which is ideal to keep the food flavor intact. Nutritive value contains both tocopherols as well as tocotrienols and Q10 enzymes. It has got unique symmetrical triacylglycerol of the type SUS, which is ideal for application as cocoa butter equivalent. Balanced fatty acids, which is ideal for the preparation of multi-source edible oil. Naturally solids at 20 degrees centigrade, so no hydrogenation is required. It is ideal for the preparation of trans-free product to meet the TFA regulation. Absolutely no scientific evidence to link consumption of palm oil with lifestyle disease such as cardiovascular disease, obesity, diabetes, and even cancer. However, as a scientist, I advise to take balanced SAFA, MUFA, PUFA ratio as per the recommendation by ICMR by rotating 2 or more vegetable oils to get the benefit of each oil. I will never suggest you to take only palmolene. Keep rotating the oil so that you get a balanced fatty acid. Last but not the least, I just want to mention that it is not appropriate to judge oil on the basis of only saturated fatty acid content, neglecting other nutritional and structural benefits. Thank you for your kind patience. I finished it before you appear.
Thank you, Dr. Kanjilal, for that comprehensive and enlightening presentation. Please wait. May I call Mr. Manchanda again on the dais? Dr. Churi, please, Dr. Rajiv Churi, please come here on the dais to give the memento to Dr. Kanjilal. Thank you, Dr. Churi. Dr. Churi, please wait once again. Please wait 1 minute. Please wait 1 minute. Yeah. We always worried about contamination. Yes. Dr. Vipra Sharma, Fair Labs Private Limited, Gurgaon, Haryana, will now give some knowledge on its detection and quantification. Topic of her lecture is detection and quantification of process contaminants in palm oil. Dr. Vipra Sharma completed her MTech in Biotechnology from the ICAR, National Dairy Research Institute, Karnal, followed by a PhD from AIIMS, New Delhi, specializing in proteomics and mass spectrometry. She brings extensive experience in the method development, validation, and optimization of residue analysis for pesticides, antibiotics, mycotoxins, etc. Dr. Sharma is well versed in advanced analytical methodologies and brings valuable technical insights to the field. She will be felicitated now by Dr. Churi. Thank you, Dr. Churi. Dr. Sharma, now it's yours.
Good evening, all of you present here. I thank organizers for giving me the opportunity to present my presentation, and Fair Labs on behalf of Dr. Samaya Arukali, who is the expert in this field, but I am being naive is given the opportunity to present behalf on this. So my topic of presentation is detection and quantification of process contaminants in palm oil. I'll be covering some aspects from introduction, how they are formed, how are they being harmful, what are their MRLs, analysis, and how can mitigate them. So starting with the introduction, as we all know, edible oils get produced from different commodities, including fruit, seeds, and nuts. But their refining process makes them to present of process contaminants that we call as 2 MCPDs, 3 and glycidyl esters. MCPDs are known as, are have full form of monochloropropane diols, and it is during the deodorization process when they are being refining at high temperatures, they give rise to two forms, either in the form of esters or free forms, and are responsible for being harmful to our human consumption. So point is, how do they actually get into our form to be different? So as we know that crude oil in palm oil when it is in crude form contains no esteric forms of MCPDs or anything. But during the process of deodorization, when they are kept boiling and heating at high temperatures, they get refined, and there we can detect different esteric forms of MCPDs or glycidyl esters. So point is, how do they come into existence? So the specific precursors, including monoacyl glycerols, when they come in contact with water, they form bound form of glycidols, and that we call as glycidyl esters. On the other hand, MCPDs, when come in contact with chlorine, inorganic chlorine, during the process of refining, then they come to form in the form of bound MCPDs that we call as MCPDs fatty acid esters. So why are they harmful? Because 3 MCPDs are responsible for causing kidney problems, reproductive toxicity in males, and mainly carcinogenicity, calling them as group 2B agent. That is why they are being referred to as possible human carcinogen. On the other hand, glycidyl esters are also known as genotoxic carcinogen that manipulate our DNA and have been classified in class of group 2A agent, which we call as probably carcinogenic to humans. So organic damage, neurotoxicity, and again reproductive issues in males are responsible for their harmful impact on human health, and hence there is concern. And that is why there have been a regulation made by European Union Commission as per 2020-1322 that there should be some MRLs, maximum residual limits, above which if they are getting detected in our oil or in our food samples, they should be prohibited for human consumption. So oils and fats from coconut, maize, rapeseed, sunflower, soybean, palm kernel, and olive oil, and mixture of these oils, if the sum of 3 MCPDs in esters is found to be beyond 1,250 microgram per kg in case of MCPD and 1,000 microgram per kg in case of glycidyl ester, it is not considered good for our health. Other vegetable oils, including fish oils and oils from other marine organisms, and mixture of oils have different concentration of 2,500 microgram per kg for MCPDs and 1,000 microgram per kg for glycidyl ester. So here comes, how do we actually detect and quantify that this much amount of MCPDs and GEs are present in our oils? For that, we have 3 regulatories present. AOCS has given us 3 methods that we call as CD29A13, CD29B13, CD29C13. As per our client's requirements, we do that method, and we call it as indirect analysis. What is the difference between here is, the first method is based on esterification using acidic method, while 29B and 29C utilizes alkaline method. 29B13 is an overnight method, so it takes longer time. 29C13 is relatively shorter method. So what happens here, that we are telling that during refining process, our MCPDs and GE are in the form of esters. So we have to break that ester cleavage and bring them to free forms through the process known as transesterification. Then after transesterification, there is matrix removal where fatty acids come out of the solid. And then to quantify it, to get it resolved in our instrument, we have to derivatize it, and that component being used is PBA, that we call as phenyl boronic acid. And once it goes into our system, of GCMS, we detect them in the form of M/Z ratio of 3 peaks that you can see that first 3 MCPD followed by 2 MCPD and glycidol is getting detected. And 0.05 mg per kg, that is 5 ppm, is our maximum LOQ, limit of quantification to be detected by our instrument. And on that basis, we do our analysis. So what we do actually is that we have known standard concentration and we put internal standard in it to identify if we are getting a known linearity of it. And at different concentration, you can see here it is 100 ppb, 200 ppb, till 2000 ppb. We make our linearity, that is calibration curve, and later you can see there are 5 samples. Based on the concentration present in it, with respect to our calibration curve, we identify what is the amount of MCPDs or GEs present in that food sample, and whether it is following the criteria as per regulation, then we say it is passing the report or we can reject it. Then comes another contaminant, though it is an environmental contaminant, but it is, plays an important role in palm oil detection, and we call it as dioxins. So what are dioxins? Dioxins are persistent organic pollutants that are present in an environment in the form of dioxin, furans, and dioxin-like PCBs that we call polychlorinated biphenyl congeners. So we have 75 polychlorinated dibenzo P-dioxins and 135 polychlorinated dibenzofurans and lot many dioxin-like polychlorinated biphenyls that are very harmful for being present in our oil samples. So when I'm saying congeners, so congeners are nothing but individual compounds that I'm talking about 135 in numbers, 75 in numbers, that are toxic and their position and the structure is changing with respect to chlorine. And we have found that congeners with 2378 chlorination pattern show highest toxicity. And their advantage to be present in oil is because they are present in environment, so they are highly persistent. And being lipophilic in nature and toxic, they get dissolved in oil matrix. So these are the different form of congeners we are talking about, but as I told you, 2378 forms the highly toxic matrix. So all at the above is the highly toxic ones, and how we pronounce it is like 2378 tetrachloro dibenzo dioxins, likewise, and P is for penta, HX for hexa. So nothing to discuss here much. It is just a list of highly toxic dioxins present in our environment that comes to our oil samples and is harmful. So why are we talking about dioxin here is because during industrial waste management or waste liberation in the form of incineration, production and disposal, open burning, through the environment and air, they somehow get trapped into, you can say, in the palm fruit, over the palm fruit, soil, and through the process of leaching and the different processes, it gets accumulated into our food samples and take entry into food chain. As a result of this, along with MCPDs and GEs, detection of dioxins becomes an important part. So dioxins like PCBs, being fat soluble, tend to accumulate in body fat, both in animals and humans, and becomes part of our food chain, and hence detection in oil becomes a mandate task. So harmful effect being their double toxicity, immunotoxicity, reproductive effects and tetragenicity, endocrine disruption, and carcinogenicity. Because of this, we have maximal residual limits given to us by Commission regulation of EU from regulatory 1259/2011, which says in vegetables, oils, and fats, if PCDD with toxicity equivalent factor 0.75 picogram per gram of fat, if it is present, it is very harmful for our health. Similarly, 1.25 picogram per gram fat as for PCDD, FPCB as per toxicity equivalent factor, and 40 nanogram per nanogram fat for non-dioxin like PCBs molecules. So this confirms that even in PPB quantities, if they are present in our oil samples, it could be very harmful and get accumulated on our food chain and may be responsible for the disease we are not even thinking about. So point is, how do we analyze these dioxins? Dioxins are the for detection of dioxins, we have very critical and complex mechanism to be detected. And here we see this is a FMS Easy Prep cartridge system, which compose of 3 cartridges. And it is a very costly and critical equipment. And importance for this is that it has very low time requirement, column packing inaccuracies are minimized, and we have very lower solvent requirement. To understand this, here is a chromatography column that are adjacently one next to each other are arranged. Here we can see that first column is multi-layer silica column, second column is carbon column, and third column is alumina column. So as soon as we input our oil sample into the first cartridge, all polar and lipid molecules interference are removed, and while it is coming to the F1 column, only those molecules that have coplanar structure or flat structure like PCDDs, polychloro-dibenzodioxins, get retained into it. Further, when it is passed through, it goes through column of alumina. There only polychloro PCBs are retained and other molecules are gone. So what happens when sample is being injected? You can see there is a W, that means waste. W here stands red for hexane. So this is all being done oil, hexane, hexane, and this way it is getting eluted. All those molecules are taken, and you can say nitrogen evaporation is done. Those are concentrated and those are dissolved in nonane, and through that they are detected on GCMS. But the reporting, the remaining part that is still bound to the cartridge is further taken by this black line, that is we are calling toluene. Now molecules, those will be dissolved in toluene, will be taken out, and those includes PCBs and MOPCBs. So MO stands for monoortho polychlorinated biphenyls. So this way we identify our identify our dioxins, and detection limit is set for it using internal standards. And the way we did for the MCPDs, the same way we prepare our samples using cartridges method, and setting up the calibration curve. If it comes out to be right, based on our reference standard, we identify the peak and give what is being present in sample, and it is reported accordingly. So here comes the point, how can we mitigate the use of MCPDs and dioxins? For that we have to provide some set mandatory and outlines how to regulate industrial processes for incinerators and industrial processes, how to do remove uncontrolled combustion. Those regulatory monitoring and R&D process could lead to clean practices that could make our edible oil, especially with here we're concerning palm oil, to be safe. So these guidance covers 3 strategies of reducing contaminants through good agricultural practices, manufacturing practices, and selection use of refined oils in food products. So that's all from my side. Thank you.
Thank you. Thank you, Dr. Sharma. May I request Mr. Manchanda here, yeah, please, on the dais, to give her a memento. Thank you, Dr. Sharma. Now, Mr. Manchanda, President OTAI Eastern Zone, will make a special announcement.
Hello. Hello. There is an announcement. East Zone has decided to give a special award to Professor Ranjana Das for her tremendous contribution towards successfully organizing this OTI annual convention and international conference. National President Dr. Rajiv Chiri has also supported our decision. There is a congratulations to Dr. Ranjana Das. You will get a special award from Eastern Zone side. It is supported by Dr. Jahan. To you, sir. It is an announcement, sir.
Thanks, Dr. Das, for your all-around contribution to make this conference successful. Thank you. Now, finally, it's time to thank our sponsors, organizing committee members, and volunteers for their tireless efforts in making this event possible. Their dedication and teamwork have turned months of preparation into reality today. To formally conclude the MPOC session and also this session, I invite Mr. Ajoy Kumar Mishra, Honorary Secretary, OTAI EZ, to deliver the vote of thanks. But before it's time for me to say goodbye to all of you, thanks a lot for bearing me for such a long time. As we conclude the news bulletin in Doordarshan Kendra Kolkata with the weather forecast, I just only can say, Besh Korom. Even it's really hot even at the end of November months. Thank you. Thank you very much. Thanks a lot.
Good evening, everyone. On behalf of organizing committee, I sincerely thank our chief guest, speaker, and second session chair for their time and valuable insight. We are grateful our collaborating institution, sponsored partner for their constant support. I special thank to organizing team, technical staff, volunteers, and administration member for their hard work behind the session. As finally, thank for all participants and delegates, your presence as enthusiasts made the conference meaningful. Thank you for again. We look forward seeing your further edition. I requested everyone, please vote of thanks and national anthem. National anthem, I can declare vote. Okay. Thank you for.
Thank you, Mr. Sharma, Mr. Mishra, for the vote of thanks. And we want to felicitate you with the flower. And Mr. Manchandaji is presenting shawl and flower to Dr. Ajay Kumar. So before officially closing this 2 days event, I want to like you all to join us for national anthem. Please.
जनगण मनोदिनाय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंग बिंदु हिमाचल যমুনা গঙ্গা উচ্ছল জলধি তরঙ্গ তব শুভ নামে জাগে তব শুভ আশিস মাগে গাহে তব জয় গাথা জনগণ মঙ্গলদায়ক জয় হে भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, everyone. Thank you for your cooperation. Okay, just an announcement. So the program is now is done, but I'm requesting to join us for the high tea, which will be served outside. But before that, I'm requesting Mr. Martis, Mr. Rajiv Churi, and all the dignitaries present over here. You please come on the dais for a group photo. Sir, please come.
ফুলটা নেবে না ফুলটা ফুলটা প্যাকেট তো এখানে নেই দেখি হ্যাঁ উনি চাই আমি ফুল নিয়ে যাবো